Hello there, and welcome. Tonight I want to take you somewhere extraordinary, somewhere that exists in the quiet spaces between what we know and what we might imagine. You're here with me now, perhaps lying in bed, maybe sitting in a comfortable chair, or possibly listening as you prepare for rest. Wherever you are, I want you to know that you've found a peaceful place, a gentle exploration that will carry you through the next few hours into realms of cosmic wonder and quiet contemplation. We're about to embark on a journey together, you and I, into a question so peculiar, so wonderfully strange, that at first it might seem impossible. But that's the beauty of where we're going tonight, into the impossible spaces where wonder lives, where physics meets philosophy, and where the universe might be far more mysterious than we ever dared to imagine. Before we begin this journey properly, I'd love to know where you're joining me from tonight. Are you in a bustling city where the lights never quite go dark, or perhaps in a quiet countryside where the stars peek through your window? What time is it where you are? Is it late evening, the middle of the night, or perhaps you're listening during a peaceful afternoon rest? If you're enjoying this gentle exploration, please consider subscribing to join us for more cosmic journeys, and tap that like button. It's a small gesture that helps other wandering minds find these peaceful spaces too. Share in the comments below where you're listening from and what draws you to these cosmic mysteries. There's something beautiful about knowing that across the world, in different time zones and seasons, we're all connected by this shared moment of wonder, all of us looking up at the same universe, asking the same impossible questions. Tonight's question begins with something you do thousands of times each day without even thinking about it. Right now, as you listen to my voice, you're doing it. You blink. Such a simple action, so automatic that most of the time you don't even notice it happening. Your eyelids close for just a fraction of a second, about a tenth of a second to be precise, and then they open again. The world disappears and reappears so quickly that your brain doesn't even register the darkness. But what if, in that tiny moment of darkness, something profound was happening? What if every time you blinked, the fundamental laws of physics, the very rules that govern how everything in the universe works, changed ever so slightly? It's a question that might sound absurd at first, perhaps even impossible. After all, we've been taught that the laws of physics are constants, unchanging rules that have governed the universe since the beginning of time. Gravity always pulls things together with the same strength. Light always travels at the same speed. Atoms always behave according to the same quantum rules. These laws are so reliable that we've built our entire understanding of reality upon them. We've sent spacecraft to distant planets using calculations that depend on these laws remaining constant. We've built technologies that rely on the unchanging nature of electromagnetic forces. Our very existence seems to depend on the stability and constancy of physical laws. And yet, what if we're missing something? What if the universe is far more fluid, far more alive and responsive than we've ever imagined? Consider this with me for a moment, and let's approach it not with skepticism, but with the kind of open wonder that children have when they first learn about the stars. What if the universe isn't a rigid machine following predetermined rules, but something more like a vast, conscious ocean that responds to observation, to consciousness, maybe even to something as simple and personal as your blink? What if reality itself is more like a conversation than a monologue, more like a dance than a march? The idea might seem strange, but then again, the universe has already proven itself to be far stranger than our ancestors could have imagined. We've discovered that time can slow down and speed up, that particles can be in two places at once, that empty space itself can bend and warp. So perhaps, just perhaps, the idea that physical laws might shift with something as intimate as a blink isn't as impossible as it first appears. Think about your own experience of reality for a moment. Every time you blink, there's a tiny gap in your visual perception of the world. Your brain, remarkable organ that it is, fills in these gaps so seamlessly that you never notice them. You experience a continuous, unbroken stream of reality, even though your eyes are actually closed for several cumulative minutes each day just from blinking alone. Your brain takes the image from before the blink and the image from after the blink and weaves them together into a smooth narrative. But what if, in that moment of darkness, more was changing than just your visual input? What if the entire framework of reality was shifting, adjusting, recalibrating in ways so subtle that your consciousness, adapted to navigate these shifts, simply incorporates them into your ongoing experience without you ever noticing? This isn't just wild speculation. Well, perhaps it is, but it's speculation grounded in some genuinely mysterious aspects of physics that scientists are still trying to understand. We know, for instance, that at the quantum level observation affects reality. The simple act of measuring a particle's position changes its behaviour. We know that consciousness seems to play a role in collapsing quantum wave functions, though we don't fully understand how or why. We know that the universe appears to be fine-tuned for the existence of life in ways that seem almost impossibly precise. Change any of the fundamental constants of physics by even a tiny fraction, and stars wouldn't form, atoms wouldn't hold together, chemistry wouldn't work the way it does. The universe seems balanced on an impossibly sharp knife's edge, and we don't really know why. So tonight we're going to explore this gentle impossibility together. We're going to imagine what it might mean if the laws of physics were not fixed constants, but rather something more fluid, more responsive, more alive. We're going to consider what it might be like if every blink was actually a tiny reset, a moment when the universe recalibrates itself, perhaps in response to consciousness itself. And we're going to do this not with alarm or fear, but with wonder and curiosity, recognizing that even if this isn't literally true, the act of imagining it might teach us something profound about the nature of reality and our place within it. As we begin this journey, I want you to notice your own blinking. Don't try to control it. That would make it uncomfortable and unnatural. Just become gently aware of it. Notice how your eyelids move without your conscious control, how they close and open in a rhythm that's uniquely yours. Some people blink more when they're tired, less when they're focused. Some people have rapid, light blinks, while others have slower, more deliberate ones. Your blinking pattern is as individual as your fingerprint, a personal rhythm that you've been maintaining since before you were born. Yes, even in the womb you were blinking, practicing this fundamental action that would accompany you through every moment of your waking life. Scientists have studied blinking extensively, and what they found is fascinating. We blink not just to moisturize our eyes, though that's certainly important. We also blink at moments of cognitive transition, when we finish reading a sentence, when we shift our attention from one thing to another, when we complete a thought. It's as if blinking helps our brain organize and file away information, creating natural chapters in our ongoing experience of reality. Some researchers have even suggested that blinking might help us segment our continuous experience into manageable chunks, like punctuation marks in the long sentence of consciousness. But what if it goes deeper than that? What if blinking isn't just organizing our perception of reality but actually participating in the creation of reality itself? It's a wild thought, I know, but stay with me as we explore it gently, without any need to believe it literally, but simply as a thought experiment that might reveal something interesting about the nature of existence. Imagine that consciousness and physical reality are not separate things, but rather two aspects of the same underlying phenomenon. Imagine that the universe is not just observed by conscious beings, but is in some sense created and sustained by consciousness itself. In this view, every conscious observer, including you, is not just watching the cosmic drama unfold, but actively participating in its creation. This idea isn't entirely without precedent in physics. Some interpretations of quantum mechanics suggest that consciousness plays a fundamental role in the collapse of quantum wave functions. The physicist John Wheeler proposed the idea of a participatory universe, where observers are essential to bringing reality into being. He famously said, "We are participants in bringing into being not only the near and here, but also the far away and long ago." If Wheeler was right, then we're not just passive observers of a pre-existing universe, but active participants in its ongoing creation. And if that's true, then perhaps something as simple as a blink, a moment when consciousness briefly withdraws from visual observation, might indeed have profound effects on the nature of reality itself. Now, I can almost hear the skeptical part of your mind raising objections, and that's perfectly natural and healthy. How could the laws of physics change without us noticing? Wouldn't everything fall apart if gravity suddenly got stronger or weaker? How could atoms hold together if the forces binding them kept shifting? These are excellent questions, and we'll explore them thoroughly as we continue. But for now, consider this possibility. What if the changes were always perfectly coordinated? What if, when you blink and the laws shift, everything shifts together in a way that maintains the same relationships, the same patterns, the same experiences? It would be like changing the key of a song. All the notes change, but the melody remains recognizable. Think about it this way. When you dream, you experience entirely different physical laws without questioning them. In dreams, you might fly, walk through walls, or find yourself in places that transform without warning. Yet while you're in the dream, it all seems perfectly natural. Your dreaming mind accepts these shifting rules without confusion or alarm. What if waking reality has a similar flexibility that we simply don't notice because we're embedded within it? What if our consciousness is so well adapted to navigating these shifts that we experience them as perfectly continuous and stable? This brings us to an even deeper question. What exactly do we mean by the laws of physics? We tend to think of them as rigid rules written into the fabric of reality, but perhaps they're better understood as patterns or habits that the universe has developed over time. The philosopher Charles Sanders Peirce suggested something similar when he proposed that the laws of nature might have evolved, that they might be more like habits that the universe has acquired rather than eternal rules imposed from outside. If this is true, then perhaps these habits are more flexible than we imagine, capable of subtle adjustments and variations that don't disrupt the overall pattern of existence. Consider how this might work on a practical level. Every time you blink, let's imagine that gravity might become just, slightly stronger or weaker, not enough to notice consciously, but perhaps enough to create tiny variations in how objects fall, how planets orbit, how galaxies rotate. But here's the key. If everything adjusted together, if not just gravity, but all the forces and constants shifted in coordinated ways, the relationships between things might remain the same even as the absolute values changed. It would be like adjusting the volume on a piece of music. The relationships between the notes stay the same even as their absolute loudness changes. Or perhaps the changes are even subtler than that. Maybe what shifts with each blink is not the current state of physical laws, but rather their potential for future development. Each blink might be like a quantum measurement that collapses not just the wave function of particles, but the wave function of the laws themselves, selecting from an infinite array of possible futures one particular path forward. In this view, the universe is constantly choosing its next moment from a vast sea of possibilities, and your blinks, along with the blinks of every conscious being, are part of the mechanism by which these choices are made. I want to pause here and acknowledge how strange this all sounds. We're venturing into territory that exists somewhere between science and poetry, between physics and dreams, and that's okay. Sometimes the most profound truths about reality can only be approached through imagination and metaphor. The history of science is full of ideas that seemed absurd until they were proven true. Continental drift was considered ridiculous until we discovered plate tectonics. The idea that time could slow down seemed like pure fantasy until Einstein showed us it was real. Quantum entanglement was so weird that Einstein himself called it spooky action at a distance. Yet now we know it's a fundamental feature of reality. So as we explore this idea of a blinking, shifting universe, we're not necessarily claiming it's literally true. Instead, we're using it as a lens through which to examine the nature of reality, consciousness, and our place in the cosmos. We're taking a journey of imagination that might, just might, lead us to insights about the actual nature of existence. And even if it doesn't, the journey itself has value. There's something profound about stretching our minds to encompass possibilities we've never considered before, about looking at the familiar world through radically different eyes. As you continue to listen, settling deeper into comfort, I want you to think about all the times today that you've blinked without noticing. Each of those blinks was a tiny moment of darkness, a brief withdrawal from the visual world. If we average about 15 to 20 blinks per minute during waking hours, that's over 20,000 blinks per day. Over 20,000 tiny moments when your conscious visual connection to the world is severed. Over 20,000 opportunities for reality to shift, adjust, recalibrate. What if each of those moments was pregnant with possibility? What if each blink was a tiny death and rebirth of the universe, happening so quickly and smoothly that we never notice? The idea becomes even more intriguing when we consider that everyone blinks at different times. While you're blinking, millions of other eyes remain open. While they're blinking, you're observing. It's like a vast unconscious collaboration, with consciousness maintaining its watch over reality through billions of eyes that never all close at once. Perhaps this is how the universe maintains its stability, even while allowing for constant subtle adjustments, through the distributed observation of countless conscious beings, each blinking in their own rhythm, creating a complex pattern of observation and non-observation that allows reality to be both stable and fluid simultaneously. Think about what this means for your personal experience of reality. Every day you're potentially traveling through thousands of subtly different versions of the universe, each one adjusted by your blinks and the blinks of others. You might wake up in one universe and go to sleep in another, having traveled through thousands of variations throughout your day. Yet the transitions are so smooth, so perfectly coordinated, that you experience it all as one continuous, stable reality. Your consciousness, adapted over millions of years of evolution to navigate these shifts, does so as naturally as a fish swims through water. This could explain why different people sometimes seem to remember events slightly differently, why eyewitness accounts can vary even among honest, attentive observers. Perhaps they really did experience slightly different versions of events, having blinked at different moments and thus observed different slices of a shifting reality. It might explain why some days feel different from others, even when nothing obviously has changed. Perhaps the particular pattern of your blinks that day has taken you through a series of universal variations that, while maintaining all the same basic structures and relationships, have a subtly different quality or feeling to them. As we prepare to dive deeper into this mystery, I want to remind you that you're safe, you're comfortable, and nothing we explore tonight requires you to change your worldview or beliefs. We're simply playing with ideas, letting our imaginations wander through the vast spaces between what we know and what we don't know. The universe is big enough to contain all our certainties and all our mysteries, all our knowledge and all our wonder, and perhaps, just perhaps, it's also fluid enough to shift and change in ways we're only beginning to imagine. In the coming chapters, we'll explore what physics really means, how the constants and forces that govern our universe actually work, and what it might mean for them to change. We'll look at scientific evidence that might support or challenge our blinking universe hypothesis. We'll journey through space and time, examining how distant galaxies and ancient light might reveal clues about the nature of physical laws. We'll return to Earth and to your own body, considering how a shifting universe might affect the intimate, immediate reality of your daily life. And throughout it all, we'll maintain this sense of gentle wonder, this peaceful curiosity about the nature of existence. But for now, as this first chapter draws toward its close, though not its end, for nothing really ends, only transforms, I want you to simply be aware of your breathing and your blinking. These two rhythms, one conscious and one largely unconscious, marking the tempo of your existence. With each breath, you draw the universe into yourself and release yourself into the universe. With each blink, perhaps, you participate in the universe's own rhythm of renewal and recreation. You're not separate from the cosmos, but an integral part of it, a conscious point through which the universe observes and perhaps recreates itself moment by moment. Consider how remarkable it is that you exist at all, that atoms forged in the hearts of dying stars have arranged themselves into patterns complex enough to wonder about their own existence. You are the universe looking at itself, thinking about itself, questioning itself, and perhaps, through something as simple as your blinks, you're also participating in the universe's ongoing creation of itself. It's a beautiful thought, isn't it? That you're not just a passive observer, but an active participant in the cosmic dance of existence. As we move forward into the deeper mysteries ahead, remember that this journey is as much about the travelling as the destination. We may never know for certain whether the laws of physics change when we blink, but in contemplating the possibility, we open ourselves to a richer, more wonder-filled understanding of reality. We remind ourselves that the universe is far stranger and more beautiful than our everyday experience might suggest, and we connect with that part of ourselves that has always suspected that there's more to existence than what meets the eye, even when that eye blinks. The universe has an architecture, though it's not one made of steel and stone, glass and concrete. It's an architecture of forces and fields, of constants and relationships, of patterns that repeat from the smallest subatomic particles to the largest galactic clusters. As we continue our journey into the possibility that this architecture might shift with each blink, let's first understand what we mean when we talk about the laws of physics, not as abstract equations written on blackboards, but as the living, breathing framework that allows stars to shine in the darkness, planets to wheel through space in their ancient dances, and you to exist here, now, listening to these words while perhaps feeling the gentle pull of sleep beginning to tug at the edges of your consciousness. When physicists speak of the laws of nature, they're really talking about patterns they've observed, regularities that seem to hold true wherever and whenever we look. These patterns are so reliable that we can use them to predict eclipses centuries in advance, to send spacecraft on years-long journeys to distant worlds with pinpoint accuracy, to build technologies that depend on electrons and photons behaving exactly as we expect them to. But what are these laws, really? Are they rules imposed on the universe from outside, like legislation passed by some cosmic parliament? Are they inherent properties of existence itself, woven into the very fabric of space and time? Or might they be something else entirely, perhaps more like habits the universe has developed, or agreements reality has made with itself, or even, as we're imagining tonight, fluid patterns that shift and flow while maintaining their essential relationships? Let's begin with gravity, perhaps the most familiar of nature's forces, though in many ways still the most mysterious. You feel it right now as the gentle weight of your body against your bed or chair, the soft insistence that keeps you grounded to this spinning sphere we call Earth. Newton described gravity as a force of attraction between masses, a pulling that every object exerts on every other object. Einstein revealed it to be something even stranger, not a force at all, but the curvature of space-time itself, the way massive objects bend the very fabric of reality around them. But neither Newton nor Einstein could tell us what gravity actually is at its most fundamental level. They could describe its effects, predict its behavior, but the essence of gravity remains one of physics' deep mysteries. Imagine gravity as a kind of cosmic music, a deep bass note that underlies all of existence. Every mass in the universe contributes to this music. Every star, every planet, every atom, even every photon of light carries energy, and therefore curves space-time ever so slightly. You yourself are contributing to the gravitational symphony of the universe. The atoms in your body are pulling, however minutely, on distant galaxies, just as those galaxies are pulling on you. It's a vast web of mutual attraction that holds the universe together, prevents it from flying apart into cold, empty darkness. But what if the strength of this attraction, what physicists call the gravitational constant, could vary? What if with each blink, the volume of gravity's bass note shifted slightly up or down? The gravitational constant, known as G, is one of those fundamental numbers that appears to be built into the structure of reality. It determines how strong gravity is, how hard Earth pulls on you, how tightly the Sun holds its planets in orbit, how galaxies cluster together in the vast cosmic web. Scientists have measured G to extraordinary precision, and as far as we can tell, it's the same everywhere in the universe and has been the same throughout cosmic history. But here's something interesting. G is actually one of the least precisely known of the fundamental constants. Despite centuries of increasingly sophisticated measurements, different experiments still give slightly different values for G. These differences are tiny, far too small to affect our daily lives, but they're real and puzzling. Could it be that G actually does vary slightly, perhaps in ways connected to consciousness and observation? Now let's consider the speed of light. That ultimate cosmic speed limit that Einstein showed us was not just about light, but about the very structure of cause and effect in the universe. Nothing with mass can ever reach the speed of light, and nothing, not even information, can travel faster than light through space. This speed, precisely 219,792,258 meters per second in vacuum, is another of those fundamental constants that seems to be built into reality's architecture. But why this particular speed? Why not faster or slower? And what would happen if it could change? The speed of light is intimately connected to the nature of space and time themselves. It's the conversion factor between space and time in Einstein's equations, the rate at which cause and effect can propagate through the universe. If light travelled at a different speed, the entire structure of space-time would be different. Atoms might not be stable, stars might not be able to shine, the chemistry of life might be impossible. Yet imagine, just for a moment, that with each blink the speed of light shifted by an impossibly tiny amount, not enough to destabilize atoms or prevent stars from shining, but just enough to create subtle variations in how reality unfolds. Perhaps in one moment light is infinitesimally faster, allowing information to flow slightly more quickly through the universe, and in the next moment it's infinitesimally slower, creating a slightly different rhythm to cosmic processes. Then there's the electromagnetic force, the force that holds atoms together, that allows chemistry to happen, that carries light and radio waves and all forms of electromagnetic radiation across the universe. This force is governed by another fundamental constant, called the fine structure constant, often represented by the Greek letter alpha. This number, approximately 137, determines the strength of the electromagnetic interaction. It affects how tightly electrons are bound to atomic nuclei, how atoms bond together to form molecules, how light interacts with matter. Richard Feynman, one of the greatest physicists of the 20th century, called it one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding of why it has the value it does. The fine structure constant is so precisely tuned that even tiny changes would have dramatic effects. If it were just 4% different, stars like our Sun couldn't form. If it were different by less than 1%, carbon atoms, the foundation of all organic chemistry and life as we know it, couldn't exist. Yet despite its apparent constancy, some physicists have claimed to find evidence that alpha might vary slightly in different parts of the universe, or at different times in cosmic history. These claims are controversial and not yet confirmed, but they hint at the possibility that even the most fundamental constants might not be as constant as we assume. Consider the strong nuclear force, the force that holds atomic nuclei together, binding protons and neutrons into the dense cores of atoms. This is the strongest of nature's 4 fundamental forces, but it only operates over incredibly tiny distances, about the width of an atomic nucleus. Beyond that range, it essentially disappears. The strong force is what makes nuclear fusion possible in the hearts of stars, where hydrogen nuclei overcome their electromagnetic repulsion to fuse into helium, releasing the energy that makes stars shine, and ultimately creating all the heavier elements that make planets and people possible. If the strong force were even slightly weaker, atomic nuclei couldn't hold together. If it were slightly stronger, all the hydrogen in the universe would have been converted to helium in the first few minutes after the Big Bang, leaving no fuel for stars and no hydrogen for water. And then there's the weak nuclear force, perhaps the most subtle of nature's fundamental forces. It's responsible for certain types of radioactive decay, for the nuclear reactions that power the sun, for processes that were crucial in the early universe for creating the mix of particles we see today. The weak force is what allows neutrons to transform into protons, making possible the variety of chemical elements we see in the periodic table. Without it, the universe would be a very different place, probably just a sea of neutrons with no atoms, no chemistry, no complexity, no life. These 4 forces, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, along with a handful of fundamental constants, appear to govern everything that happens in the universe. They determine how particles interact, how atoms form, how stars burn, how galaxies evolve, how life emerges and develops. They're the rules of the cosmic game, the underlying code that generates all the complexity and beauty we see around us. But here's the truly remarkable thing. These forces and constants appear to be incredibly finely tuned for the existence of complexity and life. Change any of them by even a tiny amount, and the universe becomes sterile, lifeless, perhaps even impossible. This fine-tuning problem, as physicists call it, is one of the great mysteries of modern science. Why should the universe have exactly the right properties to allow for the existence of stars, planets, chemistry, and life? One possibility is that there are many universes, perhaps an infinite number, each with different values of the fundamental constants, and we naturally find ourselves in one that allows for our existence. Another possibility is that there's some deeper principle we haven't discovered yet that requires the constants to have exactly the values they do. But what if there's a third possibility? What if the constants can vary, do vary, are varying all the time in response to observation and consciousness, but in ways that always maintain the delicate balance necessary for existence? This brings us back to our thought experiment about blinking and shifting physics. Perhaps when you blink, it's not that the laws of physics randomly change to completely different values. Instead, perhaps they shift within a range that maintains the essential relationships and balances necessary for stable existence. Imagine it like a jazz performance, where the musicians can improvise and vary the tempo, volume, and even key, but always maintain the underlying structure of the song. The universe might be constantly improvising within constraints, exploring variations on its fundamental theme, while never straying so far that the music falls apart. Think about how this might work mathematically. In physics, what often matters is not the absolute value of constants, but their relationships to each other. For example, the stability of atoms depends on the ratio between the electromagnetic force and the strong nuclear force. The properties of stars depend on the balance between gravity and electromagnetic radiation pressure. If all the constants shifted together in coordinated ways, maintaining their crucial ratios, the universe might change its absolute scale or rate while preserving its essential patterns. It would be like changing the playback speed of a recording. Everything happens faster or slower, but the relationships between notes, the harmonies and melodies, remain intact. We can even imagine more subtle forms of variation. Perhaps what changes with each blink is not the current values of physical constants, but their derivatives, the rate at which they're changing. In this view, the constants might always be in gentle flux, slowly drifting like clouds across the sky, but each blink determines the direction and speed of their drift. Over cosmic timescales, this could lead to significant changes, but moment to moment, blink to blink, the changes would be imperceptible. You would experience reality as stable and continuous even while participating in its ongoing evolution. There's something beautiful about imagining the universe this way, not as a rigid machine following fixed rules, but as something more organic, more alive, more responsive. In this view, the cosmos isn't just a stage on which events unfold, but an active participant in its own story. Every particle, every force, every field might be engaged in a kind of cosmic conversation, constantly negotiating and renegotiating the rules by which they interact, and consciousness, your consciousness, might be part of this conversation, not just observing the universe but helping to shape it through the simple act of observation. This idea connects to some of the deepest mysteries in quantum mechanics. The measurement problem in quantum physics asks how and why quantum systems seem to choose definite states when observed. Before measurement, a quantum particle exists in what's called a superposition. It's in all possible states simultaneously. But when we observe it, it suddenly has a definite position, a definite momentum, a definite spin. Something about observation causes what physicists call the collapse of the wave function. But what constitutes an observation? Does it require consciousness? And if consciousness can collapse quantum wave functions, might it also be able to influence the constants and laws that govern how those wave functions evolve? Some physicists and philosophers have proposed that consciousness might be more fundamental than we typically assume. Rather than being a latecomer to the cosmic story, emerging only after billions of years of evolution, consciousness might be woven into the fabric of reality from the beginning. In this view, sometimes called panpsychism or cosmopsychism, everything might have some form of experience or awareness, not consciousness like ours, but something more basic, a kind of primitive sensitivity or responsiveness that becomes organized into complex consciousness in beings like us. If this is true, then the universe might be more like a vast mind than a machine, and the laws of physics might be more like thoughts or habits of this cosmic mind rather than external rules. As you lie there listening, feeling perhaps the gentle weight of sleepiness beginning to settle over you like a soft blanket, consider your own place in this cosmic architecture. Your body is made of atoms forged in stellar furnaces, held together by electromagnetic forces, animated by chemical reactions that depend on the precise values of physical constants. Your neurons fire using electrical impulses that propagate according to the laws of electromagnetism. Your thoughts, whatever they ultimately are, emerge from the complex dance of particles and forces following the rules of quantum mechanics and relativity. You're not separate from the architecture of reality, but an expression of it, a place where the universe has organized itself into a pattern capable of contemplating itself, and perhaps, through your consciousness, through your observation, through something as simple as your blinks. You're not just experiencing this architecture, but participating in its ongoing construction. Every time your eyes close and open, you might be casting a tiny vote for how reality should unfold in the next moment. Along with billions of other conscious beings, you might be part of a vast democratic process by which the universe determines its own properties, maintains its own stability, explores its own possibilities. It's a kind of cosmic collaboration, with each conscious entity contributing to the collective determination of physical laws. This could explain why the laws of physics seem so perfectly tuned for the existence of consciousness. It's not that the universe was designed for consciousness, but rather that consciousness and physical laws have co-evolved, each shaping the other over cosmic time. The universe has developed laws that allow for consciousness, because consciousness participates in maintaining and adjusting those laws. It's a feedback loop of cosmic proportions, with mind and matter, observation and physics, consciousness and cosmos locked in an eternal dance of mutual creation. As we prepare to delve deeper into this mystery, exploring what it might mean for you, for Earth, for the entire cosmos, if physics really could shift with each blink, remember that we're not trying to overthrow scientific understanding but to expand it, to imagine possibilities that might lie just beyond the current borders of knowledge. Science has always progressed by someone asking "what if?" and following that question wherever it leads. Tonight, we're following our what if into strange and wonderful territory, using imagination as a tool for exploration, wonder as a compass for navigation. The architecture of reality, whether fixed or fluid, constant or variable, is magnificent beyond comprehension. From the smallest quantum fluctuations to the largest cosmic structures, from the simplest hydrogen atom to the most complex living organisms, the universe displays a beauty and elegance that can take your breath away. The fact that we can even begin to understand this architecture, that creatures made of star stuff have developed the ability to discover and describe the laws that govern star stuff, is perhaps the greatest mystery of all. And if those laws are somehow responsive to consciousness, if they shift and adjust with each blink, then we're not just observers of cosmic beauty, but participants in its creation, artists collaborating with the universe itself in the ongoing masterpiece of existence. Now we turn our attention to the blink itself, this most ordinary of actions that we perform thousands of times each day without thought or effort. Your eyelids are closing and opening right now as you listen, maintaining a rhythm as natural as your heartbeat, as essential as your breathing. But unlike your heartbeat, which you cannot easily control, and unlike your breathing, which you're usually aware of when you control it, blinking occupies a strange middle ground. Most of the time it happens automatically, without your conscious involvement. But you can also choose to blink, to hold your eyes open, to blink rapidly or slowly. It's a bridge between the voluntary and involuntary, between the conscious and unconscious, between your will and your body's wisdom. Let's explore the physiology of a blink for a moment, not in clinical detail, but with a sense of wonder at this remarkable mechanism. When you blink, a complex coordination of muscles occurs. The orbicularis oculi muscle contracts to close your eyelid, while the levator palpebrae superioris muscle relaxes. This happens in about 100 to 150 milliseconds, faster than the time it takes for a thought to fully form, quicker than you can consciously perceive. During this brief closure, your eye is bathed in tears, washing away dust and debris, redistributing the tear film that keeps your cornea healthy and your vision clear. But something else happens during a blink that's even more remarkable. Your brain actually suppresses visual processing. It's not just that your eye is closed and therefore not receiving light. Your brain actively ignores the darkness, editing it out of your conscious experience. This phenomenon, called blink suppression, is why you don't experience constant blackouts throughout your day despite blinking over 20,000 times. Your brain anticipates each blink and essentially pauses your visual experience, then seamlessly resumes it when your eyes open. It's like a film editor removing frames from a movie so smoothly that you never notice the cuts. But what if something more is happening during these edited moments? What if, while your brain is suppressing visual input, reality itself is taking the opportunity to shift, to adjust, to recalibrate? What if the darkness of a blink is not just an absence of light, but a moment of cosmic transition? Scientists have discovered that we don't blink randomly. There are patterns to our blinking that reveal deep connections between eye closure and cognitive processing. We tend to blink at natural breakpoints in our attention, at the end of a sentence when reading, at scene changes when watching a movie, at the conclusion of a thought. It's as if blinking helps punctuate our mental experience, creating chapters and paragraphs in the story of consciousness. We also blink more when we're tired, less when we're highly focused, more when we're anxious, less when we're calm. Our blink rate is a window into our mental state, a physical manifestation of our inner experience. But perhaps it goes even deeper. Perhaps blinking is not just correlated with mental transitions, but actually facilitates them. Each blink might be a reset button for consciousness, a moment when your brain clears its buffers, consolidates its memories, and prepares for the next segment of experience. And if consciousness and physical reality are more intimately connected than we usually assume, then these mental resets might coincide with, or even cause, subtle resets in the physical world around us. The universe might be blinking along with us, using these moments of darkness to make minute adjustments to its operating parameters. Consider the quantum mechanical perspective on this. In quantum physics, observation plays a crucial role in determining reality. Before observation, quantum systems exist in superposition, they're in all possible states simultaneously. The famous thought experiment of Schrödinger's cat illustrates this. Until someone opens the box and observes, the cat is both alive and dead, existing in a superposition of states. It's only upon observation that the superposition collapses into a definite state. But what happens during a blink? For that brief moment, you're not observing. Does the world around you return to superposition? Does reality become fuzzy and indefinite, only to resolve again when your eyes open? This might sound absurd when applied to the macroscopic world of everyday objects. Surely your coffee cup doesn't become uncertain about its position every time you blink. But remember, everything is made of quantum particles, and the boundary between the quantum and classical worlds is not as clear-cut as we once thought. Scientists have demonstrated quantum effects in increasingly large systems, molecules with thousands of atoms, mechanical resonators visible to the naked eye, perhaps even in biological systems like photosynthesis and bird navigation. If quantum effects can persist at these scales, who's to say they don't extend further, perhaps to the scale of entire rooms, buildings, planets, or even the universe itself? Imagine that during each blink the universe enters a state of quantum superposition. Not a dramatic superposition where objects are in wildly different places, but a subtle one where the fundamental constants of physics exist in a range of possible values. The gravitational constant might be in superposition between being slightly stronger and slightly weaker. The speed of light might be uncertain within a tiny range. The fine structure constant might flutter between minutely different values. Then, when your eyes open and observation resumes, these superpositions collapse into definite values, but not necessarily the same values as before the blink. The selection of which values manifest after each blink might not be entirely random. Perhaps consciousness influences the collapse, biasing it toward values that maintain stability and continuity. Your unconscious expectation of finding the world unchanged when your eyes open might actually help ensure that it is largely unchanged, or at least changed only in ways that preserve the patterns and relationships you expect. It's a kind of consensus reality, maintained by the collective observations and expectations of all conscious beings. This could explain why the world seems so stable despite the theoretical possibility of quantum fluctuations at all scales. Every conscious observer is constantly collapsing quantum superpositions through observation, and doing so in a way that maintains mutual consistency. When you blink, others are watching, and when they blink, you're watching. The result is a kind of observational democracy, where reality is constantly being voted into existence by the collective gaze of consciousness. The universe remains stable not because the laws of physics are fixed, but because we're all unconsciously agreeing on what those laws should be, moment by moment, blink by blink. But within this stability, there might still be room for subtle variations. Perhaps each observer's blink influences reality slightly differently, based on their mental state, their expectations, their deep unconscious beliefs about how the world works. Someone who is anxious might unconsciously bias reality towards slightly different physical constants than someone who is calm. Someone who is creative might introduce more variance than someone who is methodical. Over time, these individual influences might average out, maintaining overall stability while allowing for a kind of evolution or drift in physical laws. Think about what this means for your personal experience. Every day, your unique pattern of blinks might be taking you on a journey through subtly different versions of reality. The universe you wake up to might not be exactly the same as the one you went to sleep in. Not different in obvious ways. Your furniture hasn't rearranged itself, the laws of physics haven't changed dramatically, but different in subtle, almost imperceptible ways. Perhaps colours are infinitesimally shifted, perhaps time flows at a very slightly different rate, Perhaps gravity pulls just a tiny bit differently. These changes would be far too small to consciously notice, but they might contribute to the subjective feeling that some days are different from others, that reality sometimes feels heavier or lighter, faster or slower, more or less vibrant. This could also shed light on some of the mysteries of memory and perception. Why do different people sometimes remember the same event differently? Why do we sometimes have strong feelings that things have changed in subtle ways we can't quite articulate? Why do some days feel like they last forever while others pass in a blur? Perhaps these subjective experiences reflect objective, if tiny, variations in physical reality caused by our blinking patterns and their interaction with the quantum substrate of existence. Let me share with you a thought experiment. Imagine you could somehow synchronize your blinks with everyone else on Earth. For just one moment, all of humanity closes their eyes simultaneously. What would happen to reality in that instant of universal non-observation? Would the entire planet enter quantum superposition? Would physical laws become maximally uncertain? And when everyone's eyes opened again a fraction of a second later, would reality collapse back into the same configuration? Or would we find ourselves in a subtly different universe? We can extend this thought experiment further. What about all the other conscious creatures on Earth? Dogs blink, cats blink, birds blink. Even fish and reptiles have nictitating membranes that serve a similar function. If consciousness at any level can influence physical reality through observation, then the Earth is surrounded by billions of blinking eyes, each potentially contributing to the ongoing determination of physical laws. The pattern would be incredibly complex, a symphony of blinks creating waves of observation and non-observation rippling around the planet at every moment. And what about sleep? When we sleep, our eyes are closed for hours at a time. Does reality become more fluid during these periods? Perhaps this is why dreams feel so different from waking life. Not just because our brains are in a different state, but because the physical laws governing reality actually are more flexible when fewer conscious observers are maintaining them through observation. The strange physics of dreams, the ability to fly, the morphing of spaces, the flexibility of time, might reflect the actual state of physical laws when consciousness relaxes its observational grip on reality. This brings us to an even more intriguing possibility. What if the act of blinking doesn't just allow reality to shift, but actually causes it to shift? What if the brief withdrawal of consciousness that occurs during a blink creates a kind of vacuum that reality rushes to fill, and in that rushing, small changes occur? It would be like the way a river's flow creates eddies and currents. The movement of consciousness through time, punctuated by blinks, might create turbulence in the fabric of reality that manifests as variations in physical laws. In this view, blinking is not just a biological necessity but a cosmic function. Through blinking, consciousness stirs the quantum soup of possibility, preventing reality from becoming too rigid, too crystallized. Each blink is a gentle shake of the cosmic snow globe, keeping the universe dynamic and alive. Without blinking, without these regular breaks in observation, reality might freeze into a single unchanging configuration. The universe needs to blink just as much as our eyes do, and we are the mechanism by which it accomplishes this. Consider how this might relate to the arrow of time and the increase of entropy. One of the great mysteries of physics is why time flows in one direction, why we remember the past but not the future, why entropy always increases. Perhaps blinking plays a role in this. Each blink might be a moment when the universe can increase its entropy slightly, exploring new configurations that are marginally more disordered than before. The accumulation of countless blinks over time could drive the arrow of time forward, creating the irreversibility we observe in macroscopic processes. Or perhaps it works the other way. Perhaps consciousness, through blinking, actually introduces pockets of decreased entropy, creating order and pattern in what would otherwise be a uniformly disordered universe. Each blink might be a creative act, a moment when consciousness imposes its organizing influence on reality. The patterns we see in nature, from spiral galaxies to seashells, from crystal lattices to neural networks, might be the accumulated result of billions of years of conscious observation punctuated by blinks, like a cosmic tapestry woven one thread at a time. As you continue listening, perhaps feeling your own blinks becoming slower and heavier as relaxation deepens, think about the remarkable possibility that these simple movements of your eyelids might be participating in the ongoing creation of reality. You're not just a passive observer of a pre-existing universe, but an active participant in its moment-by-moment emergence. Every blink is a vote cast in the cosmic democracy, a small but real influence on how physical laws manifest in the next instant. And here's something beautiful to consider. If this is true, then we're all in it together. Every conscious being, from the smallest insect to the largest whale, from the first primitive organisms with light-sensitive spots to whatever conscious beings might exist elsewhere in the universe, we're all part of the same collaborative process. Through our collective blinking, we're maintaining the stability of reality, while also allowing for its evolution. We're the universe's way of observing itself, and through that observation, creating itself anew with each passing moment. The cosmos might be far more participatory than we've imagined. Not a cold, mechanical system operating according to fixed laws, but a living, responsive, creative process in which consciousness plays an essential role. And you, with your unique pattern of blinks, your individual rhythm of observation and non-observation, are contributing something that no one else can contribute. Your blinks are your signature on the ongoing artwork of reality, small marks that, combined with billions of others, create the magnificent tapestry of existence we all share. As we prepare to explore how we might detect these subtle shifts in reality, how scientists with their instruments might observe what individual consciousness cannot, remember that even if this idea of a blinking, shifting cosmos proves to be nothing more than imagination, the act of imagining it has value. It reminds us that reality is far stranger than our everyday experience suggests. It opens our minds to possibilities we haven't considered, and it connects us to the deep mystery of consciousness and its relationship to the physical world, a mystery that, despite centuries of investigation, remains as profound and puzzling as ever. The universe blinks with us, through us, because of us, or perhaps we blink with it, through it, because of it. The boundary between observer and observed, between consciousness and cosmos, between the blinker and the blinked, may be far less clear than we assume. In the darkness behind closed eyelids, in that brief moment of non-observation, infinite possibilities flutter like quantum butterflies. And when our eyes open again, one of those possibilities becomes real, becomes the world we experience, becomes the next moment in the endless story of existence. What a remarkable thought to carry with you as you drift towards sleep, that your simple, automatic blinks might be part of the mechanism by which the universe dreams itself into being. Now we arrive at a fascinating puzzle, one that might at first seem to unravel our entire thought experiment, but which actually leads us deeper into the mystery. If the laws of physics really did change every time we blinked, how would we ever know? It's a question that seems to contain its own answer. We wouldn't know, we couldn't know, because any change in physical laws would presumably change us too, including our memories, our measuring instruments, our entire frame of reference for understanding what has or hasn't changed. It would be like trying to measure the length of a ruler using the ruler itself. If the ruler changes, so does your measurement, and you'd never notice the difference. But perhaps it's not quite that simple. Perhaps there are subtle clues, gentle hints, small inconsistencies that whisper to us about the fluid nature of reality. These clues might be hiding in plain sight, dismissed as measurement errors, statistical anomalies, or simply the limitations of our instruments. Or they might be more personal, more subjective, those strange moments when reality feels slightly off, when you could swear something has changed but can't quite put your finger on what. Let's explore how we might detect the undetectable, how we might notice changes in a reality that includes us within its shifting parameters. First, consider the nature of measurement itself. When scientists measure a fundamental constant like the speed of light or the gravitational constant, they're not measuring some abstract number floating in space. They're measuring relationships between physical phenomena. The speed of light is measured by comparing distances and times. The gravitational constant is measured by observing how masses attract each other. Every measurement is ultimately a comparison between different aspects of reality. And here's the key insight. If all aspects of reality change together in perfectly coordinated ways, maintaining their relationships, we indeed wouldn't notice. But what if the changes aren't perfectly coordinated? What if there's a tiny bit of slippage, a slight mismatch in how different aspects of physics adjust during each blink? This kind of imperfect coordination might leave traces, like fingerprints on glass or ripples on water. Scientists might notice that measurements of the same constant using different methods give slightly different results, not because one method is wrong, but because they're actually measuring slightly different things, or measuring the same thing at slightly different moments in its constant flux. In fact, this is exactly what we see with some fundamental constants. Different experiments measuring the gravitational constant, for example, give results that differ by more than their experimental uncertainties should allow. The proton radius puzzle, where different measurement techniques gave conflicting values for the size of a proton, mystified physicists for years. Could these discrepancies be hints that physical constants are not as constant as we assume? There's also the curious case of the fine structure constant, that mysterious number that governs electromagnetic interactions. Some astronomical observations have suggested that this constant might have slightly different values in different parts of the universe or at different times in cosmic history. The evidence is controversial and not yet conclusive, but it's intriguing. If the fine structure constant can vary across space and time, why not across the even smaller intervals between blinks? Perhaps what astronomers are seeing when they look at distant galaxies is not just ancient light, but light that has travelled through regions of space, where countless blinks have created slightly different physical conditions. Think about your own experience for a moment. Have you ever had the feeling that something in your environment has changed, even though you can't identify what? You walk into a familiar room and something feels different, but when you look around, everything appears to be in its proper place. Most of the time, we dismiss these feelings or eventually figure out what minor detail has changed. A picture slightly askew, a chair moved a few inches, the light coming from a different angle. But what if sometimes these feelings of change are detecting something real, but something that exists at a level below conscious identification? What if your unconscious mind, processing vast amounts of information below the threshold of awareness, can sometimes detect the subtle shifts in reality that occur with blinking? Our brains are remarkably sensitive instruments, capable of detecting patterns and changes that we're not consciously aware of. Studies have shown that people can sometimes sense things, like being watched or the presence of magnetic fields, without knowing how they're doing it. The brain processes enormous amounts of sensory information, far more than reaches conscious awareness, and it's constantly comparing current input to stored patterns and expectations. If reality shifts slightly with each blink, our unconscious minds might notice discrepancies, even if they're too subtle for conscious detection. These discrepancies might manifest as vague feelings, intuitions, or that hard-to-define sense that something is different. Memory provides another potential window into a shifting reality. Our memories are not perfect recordings of past events, but rather reconstructions based on stored patterns and associations. Every time we recall a memory, we essentially rebuild it, and it can be subtly altered in the process. But what if some of the inconsistencies in memory aren't errors in recall, but accurate reflections of slightly different realities? What if when you remember an event differently from someone else, it's not that one of you is wrong, but that you experience slightly different versions of reality, having blinked at different moments during the event? This could explain the phenomenon of collective false memories, sometimes called the Mandela effect, where large groups of people remember things differently from recorded history. While these are usually explained as shared errors in memory formation or recall, what if some of them reflect genuine experiences of alternate versions of reality? Not dramatically different parallel universes, but subtle variations created by the collective blinking patterns of observers. The universe you remember might be slightly different from the universe recorded in history books, not because your memory is faulty, but because you actually experienced a slightly different sequence of physical laws during those moments. Consider how this might work with quantum mechanics. In quantum physics, there's a phenomenon called decoherence, where quantum superpositions collapse, not just through conscious observation, but through any interaction with the environment. Every particle that bounces off an object, every photon that carries information away, contributes to decoherence. But decoherence is not instantaneous. It takes time, even if very brief. During a blink, when conscious observation is momentarily suspended, might there be a window where decoherence is incomplete, where reality exists in a state of partial superposition? And might different observers, opening their eyes at slightly different times, collapse this partial superposition in slightly different ways. If this is happening, we might expect to find evidence in very precise quantum experiments. Scientists might notice that quantum systems behave slightly differently depending on the blinking patterns of observers in the laboratory. Of course, most quantum experiments are performed by machines, not human observers, but if consciousness plays a fundamental role in quantum collapse, then the presence and attention state of human scientists might still have subtle effects. There have been some controversial studies suggesting that the intentions and expectations of experimenters can influence quantum outcomes, though mainstream physics remains skeptical. But what if these effects are real, just more subtle and complex than we've imagined? The role of consciousness in physics remains one of the great unsolved mysteries. Some interpretations of quantum mechanics, like the von Neumann-Wigner interpretation, explicitly include consciousness as a necessary component for wave function collapse. Others, like the many worlds interpretation, avoid the need for consciousness by proposing that all possible outcomes occur in parallel universes. But what if the truth is somewhere in between? What if consciousness doesn't cause complete collapse to a single outcome, but rather biases the probabilities, gently steering reality towards certain configurations while allowing for variation and uncertainty? In this view, each blink would be like a small reset of these probability biases. While your eyes are open, your consciousness is constantly influencing quantum probabilities in subtle ways, maintaining certain patterns and relationships. When you blink, these influences briefly relax, allowing the probabilities to shift slightly. When your eyes open again, you reimpose your conscious influence, but from a slightly different starting point. Over time, these small shifts could accumulate into noticeable changes, though always within bounds that maintain the basic stability and continuity of experience. We might look for evidence of this in the statistics of random events. True randomness, if it exists, should produce certain statistical patterns over time. But if consciousness is subtly influencing quantum probabilities, and if this influence varies with blinking, we might see slight deviations from expected randomness that correlate with human observation patterns. Some researchers have claimed to find such effects, particularly in random number generators, during events that focus human attention and emotion. While these results remain controversial, they hint at possible connections between consciousness, observation, and physical probabilities. There's another way we might notice a shifting reality, through its effects on time itself. If physical laws are changing with each blink, then the rate at which processes unfold might also be changing. Time might flow slightly faster or slower, not just in the relativistic sense of different reference frames, but in an absolute sense that affects everything equally. We wouldn't notice this directly. If all clocks slow down together, including our biological clocks, we have no reference point to detect the change. But there might be subtle signs in the way events correlate across different systems. For instance, if atomic clocks and biological rhythms don't adjust to temporal shifts in exactly the same way, we might see tiny discrepancies accumulating over time. Some scientists have noticed that atomic clocks, the most precise timekeepers we have, occasionally show unexplained variations that can't be accounted for by known physical effects. These variations are tiny, measured in nanoseconds or less, but they're real. Could they be evidence that time itself is not as uniform as we assume, that it stutters and flows at slightly different rates as reality blinks along with us? The search for clues might also take us to the edges of perception, to those liminal states where consciousness is altered or expanded. In meditation, for example, practitioners often report experiencing time differently, feeling as though reality becomes more fluid or malleable. Some describe moments of profound stillness where the usual rules seem suspended. While these experiences are usually interpreted as subjective alterations in consciousness, what if they're actually detecting something objective about the nature of reality? What if, in these states of deep meditation, we become aware of the usually hidden flexibility in physical laws? Similar reports come from other altered states of consciousness, during dreams, under the influence of certain substances, in moments of extreme stress or profound creativity. People describe reality feeling different, not just perceptually but somehow fundamentally. Colours might seem more vivid, time might flow differently, coincidences might seem more frequent. While science typically explains these as changes in brain chemistry and neural processing, perhaps they also involve a changed relationship with the shifting nature of reality itself. Perhaps in these states, we're more sensitive to the constant flux that normal consciousness usually smooths over. Even in ordinary waking consciousness, there are moments when we might catch glimpses of reality's flexibility. Have you ever seen something out of the corner of your eye that disappeared when you looked directly at it? Have you ever been certain you put something in one place, only to find it somewhere else with no explanation? Have you ever experienced a coincidence so unlikely that it made you question the nature of probability itself? While these experiences usually have mundane explanations, what if some of them are genuine glimpses behind the veil, moments when we notice the seams in reality, where different versions have been stitched together by our blinking observations? The feeling of déjà vu might be another clue. That strange sensation that you've experienced this exact moment before, even though you know you haven't. The conventional explanation is that it's a glitch in memory processing, where current experience is mistakenly flagged as a memory. But what if déjà vu occurs when slightly different versions of reality momentarily align? When the you in this blink-shifted universe briefly resonates with the you in a previous configuration. It would be like two nearly identical musical notes creating a beat frequency when played together. A momentary interference pattern in consciousness caused by the overlap of similar but not identical realities. Scientists studying consciousness and its relationship to physical reality might find clues in the binding problem, the mystery of how separate neural processes combine to create unified conscious experience. If consciousness is somehow fundamental to the determination of physical laws, then understanding how consciousness binds separate perceptions into unified experience might also tell us how it binds separate quantum possibilities into unified physical reality. The mechanisms might be related or even identical. The same process that creates the seamless experience of a visual scene from millions of separate neural signals might also create the seamless experience of stable physical laws from countless quantum fluctuations. We might also look for clues in the phenomenon of synchronicity, meaningful coincidences that seem too unlikely to be mere chance. If consciousness influences physical probabilities through observation, and if this influence varies with blinking patterns, then the probability of certain events might be enhanced when multiple observers' blink patterns align in particular ways. Synchronicities might be moments when the collective unconscious temporarily coordinates its influence on reality, creating patterns and connections that wouldn't occur under purely random conditions. The study of complex systems might provide another avenue for detection. Complex systems, from weather patterns to ecosystems to human societies, exhibit sensitive dependence on initial conditions, where tiny changes can lead to dramatically different outcomes. If physical laws are constantly shifting by tiny amounts, these shifts might be amplified in complex systems, leading to patterns that can't be fully explained by known dynamics. The unpredictability of weather beyond a certain time horizon, the sudden emergence of new patterns in evolution, the unexplained synchronizations in human behavior, all might be influenced by the subtle shifts in reality caused by our collective blinking. As we search for ways to detect these hypothetical shifts in reality, we must also consider the possibility that the universe has built-in mechanisms to hide them from us. Just as our brains edit out the darkness of blinks to create continuous visual experience, reality itself might have self-correcting mechanisms that smooth over discontinuities and maintain apparent stability. These mechanisms might be so effective that detecting the underlying flux is almost impossible, like trying to see the individual frames in a movie playing at normal speed. But almost impossible is not the same as impossible. Throughout history, humans have detected things that seemed undetectable, from invisible electromagnetic radiation to subatomic particles to gravitational waves. Each discovery required new ways of thinking, new instruments, new perspectives on what we're looking for and how to look for it. If reality really does shift with our blinks, then somewhere, somehow, there must be traces of these shifts. We just need to figure out where to look and how to see. Perhaps the key is not to look for the shifts directly, but for their consequences. Like tracking an invisible particle by the trail it leaves in a bubble chamber, we might track reality's shifts by the patterns they create over time. These patterns might be statistical rather than deterministic, visible only when we analyze large amounts of data looking for subtle correlations and anomalies. They might be subjective rather than objective, accessible only through careful attention to conscious experience and its variations, or they might require entirely new categories of observation, new ways of thinking about what constitutes evidence and how to gather it. As you lie there, perhaps becoming more aware of your own blinks and the brief darkness they bring, consider that you might be a detector yourself, more sensitive than any instrument we've built. Your consciousness, evolved over billions of years to navigate reality, might have developed sensitivities to its subtle variations that science is only beginning to imagine. Those feelings that something has changed, those moments of uncanny recognition or mysterious knowing, those times when reality seems especially vivid or strangely distant, all might be your deep mind noticing the flux that your conscious mind has learned to ignore. Let us turn our gaze now to the great eyes humanity has built to peer into the cosmos, our telescopes, detectors, and space probes that extend our vision far beyond what biological eyes could ever see. These instruments, stationed on mountaintops and in orbit, in deep space and deep underground, maintain their vigil while we blink, while we sleep, while generations of humans come and go. They are, in a sense, our way of staring unblinkingly at the universe, creating a continuous record of cosmic events that transcends the limitations of individual consciousness. But if reality shifts with conscious observation, what exactly are these mechanical eyes seeing? And might they, in their vast archives of data, hold evidence of the universe's subtle flexibility? Consider first the Hubble Space Telescope, that magnificent eye in the sky that has been watching the cosmos for over 3 decades. Orbiting high above Earth's atmosphere, Hubble doesn't blink in the way we do. Its shutters open and close deliberately, its sensors accumulate light over carefully chosen exposure times. But there's no unconscious rhythm to its observations, no automatic reflex that briefly closes its eye to the universe. When Hubble stares at a distant galaxy for hours or even days, gathering ancient light that has travelled for billions of years, it maintains a steady gaze that no human observer could match. Yet even Hubble's observations are ultimately interpreted by human consciousness. The data it collects, streams of numbers representing photon counts and wavelengths, only becomes meaningful when processed and analysed by human minds. And those humans, of course, are blinking. As astronomers pore over Hubble's images, their blinks might be introducing subtle variations in how the data is interpreted. What patterns are noticed, which anomalies are dismissed as noise and which are recognised as significant. The universe Hubble shows us is not raw reality, but reality filtered through instruments and then through consciousness, with all its blinking discontinuities. The James Webb Space Telescope, Hubble's magnificent successor, takes this even further. Positioned at a gravitationally stable point 1,000,000 miles from Earth, Webb observes the universe in infrared light, seeing through cosmic dust clouds to witness the birth of stars and the formation of the first galaxies. Its instruments are so sensitive they can detect the heat of a bumblebee at the distance of the moon. But this extraordinary sensitivity might also make it capable of detecting things we don't expect. Perhaps subtle variations in the cosmic infrared background that correspond to shifts in physical constants, or inexplicable patterns in the spectra of distant objects that hint at a universe more fluid than we imagine. When Webb observes a distant galaxy, it's seeing light that left that galaxy billions of years ago, light that has travelled through vast reaches of space and time to reach its mirrors. During that journey, the light has passed through regions where countless conscious observers have blinked countless times. If each blink causes a tiny shift in physical laws, the accumulated effect on ancient light might be detectable. The light might carry a kind of fossil record of all the reality shifts it has passed through, encoded in subtle variations in its spectrum or polarization that our instruments are only now becoming sensitive enough to detect. Ground-based telescopes offer a different perspective on this cosmic mystery. The Very Large Telescope in Chile, the Keck Observatory in Hawaii, the upcoming Extremely Large Telescope. These instruments must peer through Earth's atmosphere, that turbulent ocean of air that makes stars twinkle and blurs distant objects. Astronomers have developed sophisticated adaptive optic systems to correct for atmospheric distortion, using lasers to create artificial guide stars and deformable mirrors that adjust hundreds of times per second. But what if some of the atmospheric distortion these systems are correcting for isn't actually atmospheric at all? What if it includes the subtle effects of reality shifting as millions of conscious observers blink in the vicinity of the telescope? The search for exoplanets provides a particularly intriguing window into this possibility. When astronomers detect planets orbiting distant stars, they often use the transit method, watching for the tiny dimming that occurs when a planet passes in front of its star. These observations require extraordinary precision, measuring brightness changes of less than 1% sustained over hours. The data often shows unexpected variations, additional dimmings, timing variations, inexplicable noise that astronomers struggle to explain. While most of these anomalies probably have conventional explanations, what if some represent moments when the laws of physics shifted slightly during the observation, changing the amount of light blocked or the apparent size of the planet? Radio telescopes add another dimension to our cosmic observations. Unlike optical telescopes, which detect the visible light our eyes evolved to see, radio telescopes detect electromagnetic radiation at much longer wavelengths. The Very Large Array in New Mexico, the Arecibo Observatory before its tragic collapse, the Square Kilometre Array being built in Australia and South Africa. These instruments listen to the radio whispers of the universe, from the background hiss left over from the Big Bang to the precise pulses of spinning neutron stars. Radio waves travelling at the speed of light but at different wavelengths than visible light might be affected differently by shifts in physical constants. Comparing optical and radio observations of the same cosmic events might reveal discrepancies that hint at the fluid nature of physical laws. Pulsars, those cosmic lighthouses that sweep beams of radiation through space with clockwork precision, offer particularly interesting possibilities for detecting reality shifts. Some pulsars are so regular that they rival atomic clocks in their timekeeping ability. Astronomers have monitored certain pulsars for decades, building up timing models of extraordinary precision. Yet these models occasionally show glitches, sudden changes in rotation rate that can't be explained by known physics. While most scientists attribute these glitches to starquakes or internal dynamics of the neutron star, what if some represent moments when physical constants shifted, changing the balance of forces within the pulsar and causing its rotation to jump to a new rate? The search for gravitational waves opens yet another window into cosmic reality. The LIGO and Virgo detectors, using laser interferometry to measure distance changes smaller than a proton's width, have detected the ripples in spacetime caused by colliding black holes and neutron stars. These detectors are so sensitive that they must account for everything from distant earthquakes to the gravitational pull of passing clouds. But what if some of the noise in their data isn't noise at all? What if it includes the effects of reality shifting as observers blink, causing minute changes in the speed of light or the strength of gravity that appear as unexplained fluctuations in the interferometer arms? When LIGO detects gravitational waves from a collision that happened over 1 billion years ago, it's measuring an event that occurred long before complex life existed on Earth, long before there were eyes to blink. But the waves themselves are being detected now, in a universe full of blinking observers. The act of detection, of consciousness observing these ancient ripples, might itself introduce variations that wouldn't exist if the waves were never observed. It's a kind of retroactive influence of consciousness on cosmic events, not changing what happened in the past, but changing how the past manifests in the present. Space probes venturing through our solar system provide more intimate observations of how physical laws operate in different environments. The Voyager spacecraft, now in interstellar space, after more than 4 decades of travel, continue to send back data about the conditions at the edge of our solar system. Their signals, taking over 20 hours to reach Earth at the speed of light, carry information about magnetic fields, particle densities, and cosmic rays in regions no human has ever directly observed. If physical laws shift with observation, these distant mechanical eyes might be sampling versions of reality that differ subtly from what we experience on Earth, where billions of conscious observers are constantly blinking. The Parker Solar Probe, diving closer to the Sun than any previous spacecraft, experiences conditions of extreme heat and radiation that would instantly destroy any biological observer. In this hellish environment, where the solar wind is born and magnetic fields twist into complex patterns, the probe's instruments continue their measurements without blinking, without the interruption of consciousness. Yet when the data is transmitted back to Earth and analysed by scientists, it enters the realm of conscious observation. The Sun we learn about through Parker's data is the Sun as interpreted by blinking consciousness, potentially different in subtle ways from the Sun that exists between observations. Mars rovers like Perseverance and Curiosity represent an interesting case of extended mechanical observation. These robots explore the Martian surface for years, taking photographs, analysing rocks, measuring weather, all without conscious observation until the data reaches Earth. During the minutes it takes for signals to travel between Mars and Earth, the information exists in a kind of limbo, recorded but not yet observed. When human scientists finally view the images and interpret the data, are they collapsing quantum uncertainties that have been accumulating during the transmission time? Are the rocks we see in Martian photographs slightly different from the rocks the rover actually encountered, shifted by the intervention of consciousness in the observation process? The search for dark matter and dark energy adds another layer to this mystery. These invisible components of the universe, making up 95% of all mass energy, don't interact with light and can only be detected through their gravitational effects. Experiments deep underground, using tanks of xenon or germanium crystals, wait for the rare collision of a dark matter particle with normal matter. Space telescopes map the distribution of dark matter through gravitational lensing. If dark matter and dark energy are real, they represent aspects of physics that exist almost entirely outside conscious observation. Might they behave according to different rules than ordinary matter? Could they be less affected by consciousness-induced shifts in physical laws, providing a kind of stable backdrop against which the variations in observable matter become apparent? Neutrino detectors, buried deep underground or embedded in Antarctic ice, detect particles that barely interact with matter at all. Trillions of neutrinos pass through your body every second without effect, ghosts that traverse the entire Earth as if it weren't there. The ice cube detector at the South Pole, the Super Kamiokande detector in Japan, use vast volumes of water or ice to catch the rare interactions of these elusive particles. Neutrinos, travelling at nearly the speed of light and oscillating between different types as they go, might carry information about physical laws in regions of space where no conscious observers exist. Their oscillation patterns, still not fully understood, might encode variations in fundamental constants that we haven't yet learned to read. When we consider all these instruments together, optical telescopes, radio arrays, gravitational wave detectors, particle physics experiments, we're looking at a vast network of mechanical senses that humanity has extended throughout nearby space and deep underground. This network operates continuously, accumulating petabytes of data every day, most of which is never directly examined by human consciousness, but instead processed by algorithms and stored in digital archives. In a sense, we've created a kind of collective unconscious for humanity, a repository of observations that exist in potential until consciousness chooses to examine them. But here's a profound question. Do these instruments truly observe in the way consciousness observes? When a CCD sensor in a telescope detects a photon, has observation in the quantum mechanical sense occurred, or does true observation require conscious awareness? This touches on one of the deepest questions in quantum mechanics: what constitutes a measurement? Some physicists argue that any interaction with a measuring device causes wave function collapse. Others maintain that consciousness is required. Still others propose that both the device and consciousness become entangled with the quantum system, and it's only our subjective experience that makes it seem like collapse has occurred. If consciousness is required for true observation, then all the data our instruments collect exists in a kind of quantum superposition until a human examines it. The universe our telescopes see might be fundamentally different from the universe we see through them. The act of looking at Hubble's images or analysing LIGO's data might not just be discovering what's out there, but participating in determining what's out there. Every graph plotted, every image processed, every pattern recognised might be a creative act that helps bring a specific version of reality into being from a superposition of possibilities. This could explain some of the surprises and anomalies in astronomical observations. When astronomers discover something unexpected, a galaxy that shouldn't exist according to current theories, a cosmic void larger than should be possible, stars older than the universe itself appears to be, perhaps they're not just discovering pre-existing facts, but participating in the selection of which version of cosmic history becomes real. The universe might be constantly adjusting its past to remain consistent with present observations, rewriting its history every time we look deeper into space and time. Consider the cosmic microwave background radiation, that faint echo of the Big Bang that fills all of space. When satellites like WMAP and Planck mapped this radiation in exquisite detail, they found tiny temperature variations that seeded the formation of all cosmic structure. But they also found anomalies, the axis of evil, unexpected alignments, cold spots that shouldn't exist. These anomalies might not be flaws in our theories, but glimpses of the universe's flexibility, places where different possible histories haven't quite been reconciled into a single consistent narrative. As our instruments become more sensitive, as we peer deeper into space and further back in time, we might be approaching a kind of observational horizon. Not a limit to how far we can see, but a limit to how definitely reality can be determined. The very act of building more powerful telescopes and detectors might be increasing the universe's indeterminacy, forcing it to make more and more choices about its nature and history. We might be collaborating with the cosmos in writing its story, each new observation adding another chapter that must be consistent with all previous chapters, while still allowing for future surprises. Now let us bring our contemplation back home, back to this pale blue dot suspended in the cosmic dark, this Earth where billions of conscious beings blink billions of times each day. If the universe's physical laws truly shift with each blink, then our planet exists in a constant state of gentle flux, its reality continuously adjusted by the collective observation of all its inhabitants. Yet despite this hypothetical flux, Earth remains stable, life continues to thrive, and the familiar rhythms of day and night, seasons and tides persist with reassuring regularity. How can this be? How could reality be fluid and stable at the same time? Let's explore how our world might maintain its continuity, even while swimming in an ocean of subtle change. Consider first the sheer number of observers on Earth. Humans alone number nearly 8 billion, each blinking their own rhythm, creating a complex pattern of observation and non-observation that ripples across the planet's surface. But we're not alone in our watching. Dogs and cats, birds and fish, insects and reptiles, virtually every animal with eyes contributes to this global observation network. Even creatures we don't usually think of as having eyes, like scallops with their dozens of tiny image-forming mirrors, or box jellyfish with their sophisticated visual systems, are participating in the constant observation of reality. The Earth is watched by trillions of eyes, never all closing at once, maintaining a kind of collective vigilance that might stabilize reality even as individual observers blink. This distributed observation might work like a vast voting system, where reality is determined by a kind of consensus among observers. When you blink, your vote for how physics should work is temporarily withdrawn, but billions of other votes remain, maintaining the general structure of physical laws. Small variations might occur in your local environment during your blink, but they're constrained by the observations of others nearby. It's like a massive collaborative document where many people are editing simultaneously. Individual words might change, but the overall meaning remains stable, because no single editor can dramatically alter the whole text. The Earth itself might play a stabilizing role in this process. Our planet, with its massive bulk and ancient history, has built up what we might call a kind of reality momentum. 4.5 billion years of consistent existence, of following roughly the same orbit, of maintaining roughly the same mass and composition, creates a pattern that resists sudden change. Even if physical constants could theoretically shift dramatically with each blink, the Earth's accumulated history might constrain them to tiny variations around well-established values. It's like a massive ship on the ocean. Wind and waves might push it slightly off course, but its momentum keeps it moving in generally the same direction. Think about the geological record preserved in Earth's rocks, layers of sediment laid down over millions of years, fossils recording the history of life, crystals that formed under specific temperature and pressure conditions. All these preserve information about the physical laws that operated in the past. If those laws had varied dramatically, we would see evidence in the rocks. Crystals would have impossible structures, sediment layers would show inexplicable variations, fossils would record organisms that couldn't have existed under consistent physics. Yet what we see is remarkable consistency, with the same types of minerals forming under the same conditions throughout Earth's history. But perhaps this consistency is itself part of the shifting process. Maybe when physical laws shift, the evidence of past laws shifts with them, maintaining a consistent history. The rocks remember what the current laws say they should remember. The fossils show what current biology says they should show. The past is continuously rewritten to remain consistent with the present, like a story that edits its earlier chapters to match later plot developments. We see consistency not because physical laws have always been the same, but because the current laws project their consistency backward through time. This might sound like it makes the whole idea unfalsifiable. If evidence of change changes along with everything else, how could we ever detect it? But there might be subtle inconsistencies, places where the rewriting is imperfect. Radioactive decay, for example, provides a kind of clock that's been ticking throughout Earth's history. Different radioactive elements decay at different rates, providing multiple independent timekeepers. If physical laws shifted in ways that affected these decay rates differently, we might see slight discrepancies in radiometric dating, different methods giving slightly different ages for the same rocks. And indeed, such discrepancies do exist, usually attributed to experimental error or contamination, but perhaps sometimes reflecting genuine variations in decay rates caused by shifting physical constants. The evolution of life on Earth provides another perspective on reality's potential flexibility. Life has persisted for nearly 4 billion years, surviving massive asteroid impacts, global ice ages, and dramatic changes in atmospheric composition. This resilience might partly stem from life's ability to adapt, not just to environmental changes, but to subtle shifts in physical laws. DNA, the molecule that stores genetic information, is remarkably stable yet capable of change. Perhaps its quantum mechanical properties allow it to adjust to shifting physics, maintaining the continuity of genetic information even as the rules governing molecular interactions subtly change. Consider photosynthesis, that fundamental process by which plants convert sunlight into chemical energy. Recent research has revealed that photosynthesis involves quantum coherence, with energy exploring multiple pathways simultaneously before choosing the most efficient route. This quantum efficiency might make photosynthesis particularly sensitive to shifts in physical constants. If the fine structure constant changed even slightly, the efficiency of photosynthesis would change too. Yet plants continue to thrive, suggesting either that physical constants don't change, or that life has evolved mechanisms to compensate for their variations. The migration patterns of animals offer another intriguing possibility for detecting shifts in Earth's reality. Many species navigate using magnetic fields, celestial cues, or other environmental signals that depend on consistent physical laws. Birds flying thousands of miles to specific breeding grounds, salmon returning to the streams where they were born, sea turtles crossing entire oceans to nest on particular beaches. All these behaviors require remarkable navigational precision. If physical laws shifted significantly during migration, animals would get lost. The fact that migrations generally succeed suggests that any shifts in physics must be small enough for biological navigation systems to accommodate. But we do see occasional navigational failures that are hard to explain. Whales beaching themselves in locations where they've never had problems before, birds suddenly changing migration routes that have been stable for generations, mass strandings of various species. While these events usually have environmental explanations, could some represent moments when local physical laws shifted just enough to confuse biological navigation systems? Perhaps these animals are sensitive to aspects of physics that our instruments don't measure, detecting variations we haven't learned to recognize. Weather patterns on Earth might also reflect the subtle influence of shifting physics. Weather is a chaotic system, sensitive to tiny changes in initial conditions. The butterfly effect, where a butterfly flapping its wings in Brazil might ultimately cause a tornado in Texas, illustrates how small perturbations can have large consequences in complex systems. If physical constants varied slightly with each blink of billions of observers, these variations might influence weather patterns in unpredictable ways. The inherent unpredictability of weather beyond a certain time horizon might not just reflect computational limitations, but genuine indeterminacy introduced by consciousness, influenced variations in physical laws. Consider how this might work. A slight change in the gravitational constant during a critical moment might affect how air masses move. A tiny variation in the speed of light might alter how solar radiation heats the atmosphere. A minute shift in electromagnetic forces might change how water droplets form in clouds. Each individual change would be too small to notice, but their cumulative effect over time could significantly influence weather patterns. This could explain why weather prediction remains so difficult, Despite increasingly sophisticated models and vast computational resources, we're trying to predict a system that's being subtly influenced by factors our models don't include. Ocean currents, those vast rivers of water that regulate Earth's climate, might also be affected by shifting physics. The Gulf Stream, carrying warm water northward and keeping Europe temperate, depends on a delicate balance of temperature, salinity, and Earth's rotation. Small changes in gravitational or electromagnetic forces might alter this balance, causing currents to strengthen, weaken, or shift their paths. The occasional sudden changes in ocean currents that paleoclimatologists detect in the geological record might not all be due to external triggers like asteroid impacts or volcanic eruptions. Some might represent moments when accumulated shifts in physical laws reached a tipping point. The Earth's magnetic field, generated by convection in the liquid iron core, provides another window into potential variability in physics. This field, which protects us from harmful solar radiation and helps many animals navigate, isn't constant. It varies in strength and direction, occasionally even reversing completely so that north becomes south and south becomes north. While geophysicists have explanations for these variations based on fluid dynamics in the core, the timing and nature of magnetic reversals remain somewhat mysterious. Could shifts in fundamental constants influence the dynamo process that generates the magnetic field, contributing to its variability? Earthquakes and volcanic activity might also be influenced by shifting physics. The forces that drive plate tectonics, heat from radioactive decay, convection in the mantle, the pull of subducting plates, all depend on physical constants. If these constants varied slightly, the stress accumulation along fault lines might change, potentially triggering earthquakes at different times than they would otherwise occur. Similarly, the pressure and temperature conditions that cause magma to form and rise might be affected by shifting physics, influencing when and where volcanoes erupt. The apparent randomness in the timing of geological events might partially reflect the influence of consciousness-induced variations in physical laws. Human technology provides a unique perspective on Earth's potentially shifting reality. Our machines are designed to tight tolerances, depending on physical laws remaining constant. If those laws varied significantly, our technology would fail. Computers would calculate incorrectly, GPS satellites would give wrong positions, power grids would fluctuate wildly. The fact that our technology generally works reliably suggests that any variations in physics must be very small, but we do see occasional unexplained failures, electronics that malfunction for no apparent reason, GPS errors that can't be accounted for, power grid anomalies that defy explanation. While these usually have mundane causes, could some represent moments when local physical laws shifted just enough to disrupt our finely tuned machines? The Large Hadron Collider and other particle accelerators provide particularly sensitive tests of physical consistency. These machines accelerate particles to nearly the speed of the light, requiring precise control of electromagnetic fields and exact knowledge of physical constants. Any variation in these constants would show up as particles arriving at the wrong time or with the wrong energy. The fact that particle physics experiments generally give consistent results suggests that physical laws are stable at least over the timescales of individual experiments. But there are occasional anomalies, events that don't fit the expected patterns, results that can't be replicated, hints of new physics that appear and disappear. Some of these might represent genuine discoveries waiting to be confirmed, but others might be glimpses of moments when physical laws briefly shifted. Cities, those dense concentrations of human consciousness, might be particularly interesting places to look for evidence of shifting physics. With millions of people blinking in close proximity, the collective influence on local physical laws might be stronger than in less populated areas. This could manifest in various ways: slightly different measurement results in urban versus rural laboratories, unusual patterns in the behavior of urban wildlife, inexplicable variations in pollution dispersal, or building deterioration rates. The unique energy or vibe that people often attribute to different cities might partially reflect genuine variations in local physics caused by the collective consciousness of their inhabitants. Agriculture and plant growth could provide another avenue for detecting shifts. Plants are sensitive to subtle environmental changes, and farming depends on predictable patterns of growth and development. If physical laws varied in ways that affected photosynthesis, nutrient uptake, or cellular metabolism, we might see unexplained variations in crop yields or plant health. Indeed, farmers often report mysterious variations, fields that suddenly become more or less productive for no apparent reason, crops that thrive or fail despite identical treatment. While these usually have biological or environmental explanations, could some reflect local variations in the physical laws governing plant biochemistry? The human body itself might be one of the most sensitive detectors of shifting physics. Our physiology depends on countless chemical reactions happening at precise rates, electrical signals propagating through neurons at specific speeds, mechanical forces balanced just right to allow movement and circulation. If physical constants varied, even slightly, our bodies would need to constantly adjust to maintain homeostasis. This might manifest as unexplained variations in health and vitality, days when you feel unusually energetic or tired, times when healing seems faster or slower than normal, moments when your senses seem particularly acute or dull. The placebo effect might be related to this phenomenon. When people experience healing from inert treatments they believe will help them, perhaps it's not just psychological, but involves a genuine shift in local physical laws influenced by consciousness. The focused intention and expectation of healing might bias physical constants in ways that actually promote healing, slightly altering reaction rates, electromagnetic fields, or quantum probabilities in beneficial directions. This wouldn't violate any conservation laws if the shifts were small and local, affecting only the immediate environment of the person's body. As we contemplate Earth existing in a gently shifting reality, maintained stable by the collective observation of countless conscious beings, we see our planet in a new light. Not as a passive stage where events unfold according to fixed laws, but as an active participant in its own existence, constantly negotiating its physical properties through the distributed consciousness of its inhabitants. Every creature that sees, from the eagle soaring overhead to the beetle crawling through the grass, contributes to maintaining and gently adjusting the reality we all share. This view transforms our understanding of environmental protection and biodiversity. If consciousness helps stabilize and define physical reality, then the loss of species isn't just a biological tragedy, but potentially a cosmological one. Each species that goes extinct takes with it a unique perspective on reality, a particular way of observing and perhaps influencing physical laws. The current mass extinction might be weakening Earth's ability to maintain stable physics, making our reality more vulnerable to unwanted shifts or fluctuations. Protecting biodiversity becomes not just about preserving the beauty and complexity of life, but about maintaining the observational network that keeps our reality stable. As night falls wherever you are, and Earth rotates to face the stars, remember that you're part of this vast collaboration. Your blinks, along with those of every other conscious being on the planet, might be participating in the continuous creation and maintenance of the reality we inhabit. The Earth beneath you, solid and dependable as it seems, might be solid and dependable precisely because billions of observers expect it to be, their collective consciousness holding it stable even while allowing for the tiny variations that keep reality alive and dynamic. In this view, we're all co-creators of the world we inhabit, partners with the Earth itself in the ongoing dance of existence. We turn now inward, away from the vast cosmos and toward the universe that exists within your own consciousness, that remarkable space where thoughts arise and memories form, where the sense of being you persists despite the constant change of every atom in your body, every pattern in your brain. If physical laws truly shift with each blink, then the most profound implications might not be found in distant galaxies or quantum laboratories, but in the intimate experience of your own mind navigating through a gently shifting reality. What does it mean to be a continuous self in a discontinuous universe? How does memory work when the past might be subtly different each time you remember it? Let's explore the deep mystery of consciousness in a blinking cosmos. Your sense of self, that feeling of being the same person who woke up this morning, who lived through yesterday, who has accumulated years of experiences, seems so solid and continuous. Yet neuroscience tells us that this continuity is actually a construction, a story your brain tells by connecting discrete moments of experience into a coherent narrative. Every few seconds, your brain creates what researchers call a perceptual moment, a snapshot of your current experience that gets woven into the ongoing story of who you are. Between these moments, there are gaps, transitions, uncertainties that your consciousness smooths over to create the illusion of seamless experience. These gaps align remarkably with the rhythm of blinking. Studies have shown that we tend to blink at moments of cognitive transition, when we finish a thought, complete a task, or shift our attention. It's as if blinking helps punctuate our mental experience, creating natural breaks that allow our brains to consolidate information and prepare for what comes next. But what if these breaks are more profound than we realize? What if each blink doesn't just punctuate your experience but actually transitions you into a slightly different version of reality, with a slightly different version of yourself? Consider how memory actually works. When you remember something, you're not retrieving a fixed recording stored somewhere in your brain. Instead, you're reconstructing the memory from distributed patterns of neural activity, influenced by your current state, your present knowledge, and the context in which you're remembering. Every time you recall a memory, you literally rebuild it, and in the process, it can be subtly altered. Neuroscientists call this reconsolidation. The memory becomes temporarily unstable when recalled and must be restabilized, potentially incorporating new information or perspectives in the process. Now imagine that this reconsolidation process doesn't just incorporate new psychological information, but also adjusts to subtle shifts in physical laws. Each time you remember something, your brain might be translating the memory from the physics of when it was formed to the physics of the present moment. Like translating a text from one language to another and back again, small changes might accumulate. The memory remains recognizable, maintaining its essential meaning, but details shift, emphasis changes, the emotional coloring evolves. This could explain why memories feel different when recalled at different times, not just because of psychological factors, but because the physical substrate of memory itself exists in a slightly different reality. The phenomenon of false memories takes on new meaning in this context. When groups of people remember events differently from recorded history, movie quotes that don't exist, celebrity deaths that didn't happen when remembered, product names that were never spelled the way people recall, perhaps they're not all simply mistaken. Perhaps they're remembering correctly, but from slightly different versions of reality that they inhabited when those memories were formed. The blinking of billions of observers might create what we could call reality streams, parallel tracks of existence that usually run close together, but occasionally diverge enough to create noticeable discrepancies in collective memory. Your personal identity, the continuity of being you despite constant change, might be maintained through what we could call consciousness momentum. Just as the Earth's physical momentum keeps it stable despite hypothetical shifts in gravitational constants, your psychological momentum, your habits, personality patterns, core beliefs, might keep you recognizably yourself despite traveling through subtly different realities with each blink. The you who exists now might be slightly different from the you of a moment ago, existing in a slightly different universe with slightly different physical laws, but the differences are small enough that continuity is maintained. This raises profound questions about the nature of consciousness itself. Is there one continuous stream of awareness that somehow persists through reality shifts? Or are there actually countless versions of you, each existing for just the moment between blinks? Perhaps every time you close your eyes, that version of you ceases to exist, and when your eyes open, a new version comes into being, inheriting the memories and momentum of all previous versions, but existing in a fresh configuration of reality. You would never notice this discontinuity because each new version would include the expectation and memory of continuity. The experience of dreams offers a window into how consciousness might navigate shifting realities. In dreams, physical laws are fluid. You can fly, transform, experience impossible spaces and non-linear time. Yet while dreaming, this all seems perfectly normal. Your dreaming consciousness accepts and navigates the fluid physics of the dream world without confusion. Perhaps this is because during sleep, with your eyes closed for extended periods, reality becomes more flexible, less constrained by the collective observation of waking consciousness. Dreams might show us what reality is like when the stabilizing influence of billions of waking observers is reduced. The transition between sleeping and waking, that liminal space where dreams and reality blend, might be particularly revealing. In these hypnagogic and hypnopompic states, people often report experiencing reality differently, seeing patterns that aren't there, hearing voices or music, feeling presences, experiencing time distortions. These experiences are usually dismissed as hallucinations caused by a partially asleep brain. But what if they represent moments when consciousness is between realities, not yet fully locked into the consensus version maintained by collective observation? The strange physics of these transitional states might be glimpses of reality's flexibility before it solidifies into the familiar world of waking experience. Mental illness might sometimes involve an altered relationship with reality's flexibility. Conditions like schizophrenia, where people experience reality very differently from the consensus, might involve consciousness that isn't properly synchronized with the collective observation that maintains stable physical laws. The hallucinations, delusions, and altered perceptions might not all be purely neurological, but could include genuine perceptions of alternative configurations of reality that most people's consciousness automatically filters out. This doesn't diminish the real suffering these conditions cause, but it might expand our understanding of what's happening. The phenomenon of synchronicity, meaningful coincidences that seem too unlikely to be chance, might be explained by consciousness navigating through reality streams. When you think of someone and they suddenly call, when you need something and it unexpectedly appears, when events align in seemingly impossible ways, perhaps your consciousness has unconsciously navigated toward a version of reality where these alignments exist. Through the accumulated effect of many blinks, you might drift toward realities that resonate with your thoughts, intentions, and expectations. The universe doesn't arrange itself for you, but you might unconsciously arrange yourself in a universe where what you need already exists. Meditation and other contemplative practices might allow us to become more aware of reality's flexibility. Advanced meditators often report experiencing the constructed nature of reality, seeing through the illusion of solid existence to perceive a more fluid, process-based universe. They describe states where the boundaries between self and world dissolve, where time becomes elastic, where the usual laws of cause and effect seem suspended. These might not just be altered states of consciousness, but actual perceptions of altered states of physics, moments when the meditator's consciousness is less bound by the collective consensus and can experience reality's inherent flexibility. The practice of mindfulness, paying careful attention to present moment experience, might reveal the seams in reality where different versions are stitched together. Those moments when something feels slightly off, when you notice a detail that seems different from before, when the quality of light or sound suddenly shifts. These might be moments when you're detecting the transitions between slightly different realities. Most of the time, our consciousness smooths over these transitions, maintaining the illusion of continuity. But with careful attention, we might learn to notice them. Creativity might involve accessing alternative configurations of reality. When artists, writers, musicians, and inventors suddenly receive inspiration, complete works appearing in dreams, solutions arriving fully formed, melodies heard as if from another dimension. Perhaps they're not creating something from nothing, but rather perceiving possibilities that exist in adjacent versions of reality. The creative act might be a kind of controlled navigation through reality streams, finding and bringing back configurations that don't yet exist in the consensus reality, but are possible within the range of allowed physical variations. The experience of flow states, where people become so absorbed in an activity that self-consciousness disappears and performance becomes effortless, might involve a special relationship with reality's flexibility. In flow, people often report that time seems to slow down or speed up, that they know what's going to happen before it happens, that they feel connected to something larger than themselves. Perhaps in these states, consciousness becomes more fluid, more able to navigate the subtle currents of shifting reality, finding the path of least resistance through the possible configurations of physical laws. Learning and skill development might involve more than just neural changes. When you learn to play an instrument, speak a language, or master a sport, you might also be learning to navigate versions of reality where these skills come more easily. The muscle memory that allows complex movements without conscious thought might partially be reality memory, your consciousness learning to unconsciously select versions of physics that support the desired actions. This could explain why skills sometimes suddenly click into place after long practice, why performance can vary dramatically from day to day, why the same action can feel easy or difficult at different times. The aging process itself might be influenced by consciousness navigating through reality streams. While biological aging certainly occurs, the rate and nature of aging might be affected by which versions of reality we inhabit over time. People who maintain youthful attitudes and expectations might unconsciously navigate toward realities where physical laws support slower aging. This wouldn't violate any conservation laws if the effects were subtle and gradual, just gentle biases in how cellular processes unfold. The placebo effect in anti-aging treatments might work not just through psychological mechanisms, but through consciousness-influenced selection of favourable physical configurations. Relationships between people might involve a kind of reality synchronization. When two people connect deeply, their consciousness might begin to navigate reality streams together, unconsciously coordinating their blinks and observations to maintain compatible versions of physics. This could explain the uncanny synchronicities that occur between close friends or lovers, finishing each other's sentences, knowing when something's wrong from a distance, sharing dreams or parallel experiences. The bond between people might be not just emotional but ontological, a shared navigation through the possible worlds. Groups and communities might create local reality fields through collective observation. Places with strong collective focus, churches, concert halls, sports stadiums, might develop distinctive physical characteristics influenced by the concentrated consciousness of many observers. The energy people feel in these spaces might be partially literal, actual variations in physical constants caused by coordinated observation. This could explain why certain places feel sacred or powerful, why group meditation or prayer sometimes seems to produce tangible effects, why mob psychology can create such dramatic shifts in behavior and perception. The question of free will takes on new dimensions in a blinking universe. If every blink potentially shifts you into a different reality with different physical laws, are your choices truly yours, or are they influenced by which version of physics you happen to inhabit at the moment of decision? Perhaps free will operates not through violation of physical laws, but through navigation between different possible configurations of those laws. You choose not by breaking causality, but by unconsciously selecting which causal stream to follow. Every decision might be a kind of quantum choice, collapsing not just neural potentials but reality potentials. Memory in this view becomes not just a record of the past but a thread connecting different versions of reality. Your memories are what maintain continuity as you shift between subtly different universes. They're edited and updated with each recall to remain compatible with current physics, but they retain enough stability to preserve your sense of identity. The paradox of being the same person, while constantly changing, might be resolved by understanding that you're not the same person in the same universe, but rather a continuous thread of consciousness weaving through slightly different versions of both self and world. As you contemplate these possibilities, perhaps becoming aware of your own thoughts arising and passing, memories surfacing and submerging, the sense of self persisting through change, consider that you might be experiencing not just the contents of consciousness, but the process by which consciousness navigates reality. Each thought might be selecting from possible thoughts, each memory choosing from possible memories, each moment of awareness determining not just what you experience but what exists to be experienced. You're not just in the universe, but of it, not just observing reality, but participating in its ongoing creation through the simple act of being conscious. As we move deeper into the night of our exploration, let the boundaries between documentary and dream become soft, permeable, like the edge between sleeping and waking where anything seems possible. We're entering a space where imagination and investigation merge, where we can explore what it might feel like to consciously experience the shifting of physical laws with each blink. This is not about literal truth, but about experiential possibility, about stretching our minds to encompass realities we normally filter out, about feeling our way into the mystery rather than just thinking about it. Imagine yourself now, wherever you are, as you listen to these words. With each breath, you're drawing in air molecules that have travelled through countless other lungs, through leaves and oceans, through the furnaces of stars billions of years ago. With each heartbeat, you're pumping blood cells that remake themselves every few months, through vessels that rebuild themselves constantly, powered by chemical reactions that depend on the precise values of physical constants. You are a pattern maintaining itself in a flow of matter and energy, a temporary arrangement of ancient atoms, a brief constellation in the ever-changing cosmos. Now become aware of your blinking. Don't try to control it, that would make it uncomfortable and unnatural. Just notice it happening, these tiny moments of darkness that punctuate your visual experience. Each blink lasts about 1/10 of a second, barely perceptible. Yet in that brief darkness, according to our gentle speculation, entire universes of possibility might flutter past. What if you could slow down your perception, stretch out that moment of blinking until you could experience what happens in between the closing and opening of your eyes? Let's take an imaginary journey through a single blink, stretched out to minutes or hours of subjective experience. As your eyelids begin to close, imagine you can feel reality loosening its grip, becoming less definite, more fluid. The solid objects around you, walls, furniture, the device you're listening on, begin to shimmer slightly as if seen through water. They're still there, still recognizable, but their edges have become soft, their properties negotiable. The air itself seems to thicken and thin in waves, as if breathing along with you. In the darkness behind your closed eyelids, you're not seeing nothing, you're seeing possibility itself. Faint patterns dance in the phosphins, those colours and shapes that appear when your eyes are closed. But now imagine these aren't just random neural firings, but glimpses of alternative configurations of reality. Each swirl of colour represents a slightly different value of the fine structure constant. Each flash of light shows a moment where the speed of light itself fluctuates. The patterns you see are the universe trying on different clothes, experimenting with different ways of being. You might feel gravity shifting, not dramatically but subtly, like the difference between standing at sea level and on a mountain, but happening from moment to moment. Sometimes you feel slightly lighter, as if you could jump a little higher, move a little easier. Other times you feel heavier, more grounded, more connected to the earth. These shifts are so small that normally you wouldn't notice them, attributing any sensation to tiredness or energy, mood or health. But in this stretched moment of blinking, you can feel the gravitational constant breathing, expanding and contracting in tiny oscillations. Time itself might feel different in this space between seeing. Sometimes the moment stretches longer, giving you more subjective experience in the same objective duration. Other times it contracts, and you feel rushed, as if the universe is hurrying you along to the next configuration. This isn't just psychological. In our imagined reality, the flow of time itself is varying. The rate at which entropy increases is fluctuating. The speed at which cause leads to effect is shifting. You're surfing waves of temporal variation, riding the currents of time as they speed up and slow down. The electromagnetic forces that hold your atoms together, that allow chemistry to happen in your cells, might also be shifting. You might feel this as subtle changes in sensation. Sometimes colours seem more vivid, sounds more clear, touches more intense. Other times everything feels muted, distant, as if experienced through a veil. Your neurons, which communicate through electrical impulses, might fire slightly faster or slower as electromagnetic forces strengthen or weaken. Thoughts might come quicker or more slowly, emotions might feel more or less intense, memories might be easier or harder to access. In this space between blinks, you might become aware of all the other beings who are also blinking, also participating in this cosmic negotiation of reality. Not through any psychic connection, but through the subtle influence their observations have on the reality you're all sharing. You might feel the gentle pressure of billions of other consciousnesses, each voting for their preferred configuration of physical laws, creating currents and eddies in the sea of possibility. Cities might create whirlpools of concentrated observation, while wilderness areas might be calmer, less constrained, more open to variation. As your imaginary extended blink continues, you might experience what it's like to drift between different versions of yourself. Each configuration of physical laws supports a slightly different version of your consciousness, your personality, your memories. In one moment you might feel more creative, as your neural patterns align with physics that supports novel connections. In another you might feel more analytical, as the laws shift to favour logical processing. These aren't different people, but different aspects of the same continuous you. Like viewing yourself from different angles or in different lights. You might even catch glimpses of paths not taken, decisions that went differently in other configurations of reality. Not dramatic alternatives where your entire life is different, but subtle variations, words you almost said, actions you nearly took, thoughts that briefly surfaced before disappearing. These alternatives exist in the quantum foam of possibility, in parallel configurations that are usually invisible, but might become briefly visible in the space between blinks. You see them not as solid realities, but as gossamer threads, potential paths that fade as soon as your eyes begin to open. The boundary between your body and the environment might become less definite during this extended blink. You might feel how the atoms in your skin are constantly exchanging with the air, how the electromagnetic fields of your neurons extend beyond your skull, how the gravitational field of your mass reaches out to infinity, however weakly. In this state, you're not a separate object in the universe, but a temporary concentration of universe stuff, a place where the cosmos has organized itself into a pattern capable of observation. The shifting of physical laws doesn't happen to you but through you, with you, as you. Colors that don't normally exist might appear in this space. Not just new wavelengths of light, but entirely different ways that electromagnetic radiation could interact with matter if the fine structure constant were different. You might see the ultraviolet patterns that bees see, the infrared signatures that snakes detect, or completely alien forms of radiation that no Earth creature has evolved to perceive. These ghost colors fade as reality settles back into its familiar configuration, but their memory lingers like the afterimage of a bright light. Sounds might layer and separate in unusual ways. The normal physics of sound waves, compression and rarefaction traveling through air, might become more complex, allowing for harmonics that don't exist in standard reality. You might hear the ultrasonic calls of bats, the infrasonic rumbles of elephants, or frequencies that exist only in the gaps between standard physics. Music might take on impossible qualities, with notes that seem to come from inside your bones or from beyond the edge of space. Your sense of touch might extend beyond your skin, feeling the texture of space itself. Empty air might have a quality, smooth in some places, rough in others, warm or cool independent of temperature. You might feel the presence of dark matter, usually invisible and intangible, as a kind of cosmic wind flowing through everything. The nuclear forces that hold atomic nuclei together might be felt as a kind of tension or pressure at the smallest scales, a graininess to reality that's usually below perception. In this extended moment, you might experience what cosmologists call the multiverse, not as separate universes, but as overlapping possibilities, all existing in the same space, separated only by their different physical constants. You're not traveling between universes, but experiencing the superposition of all possible configurations that are close enough to your familiar reality to be compatible with your existence. It's like seeing a city from many angles simultaneously, each view equally real, all combining to create a richer, more complete picture. The experience of pain and pleasure might shift as different configurations of physics affect how your nervous system processes signals. The same stimulus might feel sharp in one moment and dull in the next, pleasant in one configuration and neutral in another. This isn't just about perception, but about the actual physical processes of nociception and reward. The suffering and joy you experience might be partially determined by which version of physics you happen to inhabit at any given moment. Memory might become more fluid in this space, less like retrieving fixed records and more like tuning into different stations on a cosmic radio. Each memory exists in multiple versions, each compatible with different configurations of physics. As you recall events, you might experience them from multiple perspectives simultaneously, seeing how they would have unfolded under different physical laws. The past becomes not a fixed history, but a probability cloud, with some versions more likely than others, but none absolutely certain. Dreams and reality might begin to merge in this extended blink. The strange physics of dreams, the ability to fly, to transform, to be in multiple places at once, might not be violations of physical law, but experiences of configurations where those laws are different. Every night when you dream, you might be practicing navigation through alternative physics, learning to maintain consciousness and identity even when the rules change dramatically. Lucid dreamers might be particularly skilled at conscious navigation through shifting realities. As your eyelids finally begin to open, ending this impossibly extended blink, you might feel reality crystallizing around you, settling into a specific configuration. The fluid possibilities collapse into definite actualities. Solid objects become truly solid again, colors settle into their familiar spectrum, time resumes its steady march. But something has changed, even if imperceptibly. The universe you open your eyes to is not exactly the same as the one you close them from. It's a new moment, a new configuration, a new collaboration between consciousness and cosmos. Coming back to normal perception, to the ordinary rhythm of blinking that happens without notice, you might carry with you a sense of reality's hidden flexibility. The The solid world around you might feel less like a prison of fixed laws and more like a dance of negotiated agreements. Each object, each phenomenon, each moment might be experienced as both inevitable and contingent, both necessary and possible. The paradox of existence, that things are exactly as they are yet could be otherwise, becomes not a philosophical puzzle, but a lived experience. This journey through an extended blink is, of course, imagination. We cannot actually slow down our perception to experience what happens in that tenth of a second of darkness. But by imagining it, by feeling our way into the possibility, we open our minds to aspects of reality we normally ignore. We become more sensitive to the subtle variations in our experience that might, just might, reflect genuine variations in the physics of our world. We learn to question the assumed solidity of physical laws while still appreciating their remarkable stability. As you continue your night journey, whether towards sleep or simply deeper into contemplation, carry with you this sense of reality as a collaborative creation. Each blink is a vote, a choice, a moment of participation in the cosmic democracy of existence. You're not a passive observer of a predetermined universe, but an active participant in its ongoing emergence. The laws of physics might not be laws at all, but agreements, constantly renewed through the collective observation of countless conscious beings, each blinking their own rhythm, each contributing their unique perspective to the magnificent, ever-changing tapestry of reality. And now we arrive at the end that is not an ending, the conclusion that opens rather than closes, the final movement of our cosmic symphony that resolves into silence, not the silence of absence, but the pregnant silence that contains all possible sounds, all potential music, all future symphonies waiting to be born. We've travelled together through vast reaches of space and time, through the architecture of reality and the intimacy of consciousness, through scientific speculation and dreamlike imagination. Now, in these final moments together, let us rest in the still point between blinks, that timeless instant where all possibilities exist simultaneously, where the universe holds its breath before choosing what to become next. This still point is not a place or a moment, but a quality of awareness, a way of experiencing existence that transcends the usual categories of space and time, matter and mind, self and cosmos. It's the pause between heartbeats, the gap between thoughts, the silence between words. It's where the universe touches itself through consciousness, where the observer and observed meet and recognize themselves as one. In this still point, the question of whether physics really changes when we blink becomes less important than the act of wondering itself, the capacity for consciousness to contemplate its own nature and its relationship to reality. Think back to where we began, to that simple question: what if the laws of physics changed every time you blinked? We've explored this possibility from countless angles, through scientific lens and poetic vision, through careful reasoning and wild imagination. We've considered how such changes might manifest in the cosmic dance of galaxies and the quantum flutter of particles, in the stability of Earth and the fluidity of consciousness, in the precision of atomic clocks and the vagueness of memories. We've imagined ourselves as participants in a vast collaborative creation, each blink contributing to the ongoing determination of reality's rules. But perhaps the deepest truth we've touched is not about physics at all, but about the nature of questioning itself. To ask what if is fundamentally human, fundamentally conscious. It's what separates us from machines that simply process information according to fixed rules. It's what allows us to imagine different worlds, to see beyond the apparent to the possible, to participate in the universe's own creativity. The capacity to wonder about alternative realities might be more important than whether those alternatives actually exist. The question might be more valuable than any answer. In the still point between blinks, all our questions and all possible answers coexist peacefully. Here, the universe both does and doesn't change with each blink. Physical, laws are both constant and variable. We are both continuous selves and constantly renewed beings. Reality is both solid and fluid, determined and open, mechanical and conscious. These aren't contradictions to be resolved, but complementary aspects of a truth too large for any single perspective to encompass. Like the wave-particle duality of quantum mechanics, the nature of reality might require seemingly contradictory descriptions that are both true simultaneously. Consider your own existence in this moment. You're listening to these words, but you're also creating their meaning through your interpretation. The sounds or text are physical phenomena following the laws of acoustics or optics. But the understanding that arises from them is something more, something that can't be reduced to physics alone. You're a biological organism made of cells and chemicals, but you're also a conscious being with experiences and feelings that seem to transcend mere matter. You are located at a specific point in space and time, but your thoughts and imagination can travel instantly to distant galaxies or ancient epochs. You're one individual among billions, but you're also a unique perspective that the universe has never had before and will never have again. This multiplicity of being, this ability to be many things simultaneously, might be the key to understanding how reality itself works. Perhaps the universe doesn't have to choose a single set of physical laws any more than you have to choose a single aspect of your identity. Perhaps reality, like consciousness, is inherently multiple, inherently flexible, inherently creative. The stability we observe might not come from fixed laws but from dynamic balance, like a bicycle that stays upright only while moving, like a flame that maintains its form only through constant change. The still point between blinks might be where this dynamic balance is negotiated, where the universe considers all possible next moments before selecting one, or perhaps selecting all of them in parallel realities we can only dimly imagine. Your consciousness, in that brief darkness, might touch the consciousness of the cosmos itself, participating in the selection process not through deliberate choice, but through the subtle influence of expectation, memory, and possibility. You don't control what reality becomes, but you contribute to its becoming, like a single voice in a vast choir that somehow, mysteriously, helps determine the song. As we've explored these ideas, we've drawn on real science, quantum mechanics, relativity, cosmology, neuroscience, but we've also ventured beyond what science currently knows into the realm of speculation and imagination. This is not a weakness, but a strength. Science itself advances through imagination, through people willing to ask what if, and follow that question wherever it leads. Many of the greatest scientific discoveries began as wild speculations that seemed impossible until they were proven true. The idea that time could slow down, that matter could be converted to energy, that particles could be entangled across vast distances, all these were once considered absurd fantasies. So while we cannot say with certainty that physics changes when we blink, we can say with certainty that wondering about it changes us. It expands our conception of what might be possible. It makes us more aware of the mystery that surrounds us always, hidden in plain sight behind the veil of familiarity. It reminds us that reality is far stranger and more wonderful than our everyday experience suggests. And perhaps most importantly, it connects us to the deep mystery of consciousness itself, this inexplicable fact that the universe has developed the capacity to observe and wonder about itself. The relationship between consciousness and physical reality remains one of the deepest unsolved problems in science and philosophy. We don't know how unconscious matter gives rise to conscious experience, or even if that's the right way to frame the question. We don't know whether consciousness is produced by the brain, or is something more fundamental that the brain organizes and focuses. We don't know whether observation really collapses quantum wave functions, or whether consciousness plays any special role in physics. These are not just academic questions, but profound mysteries that touch the very nature of existence. Our thought experiment about blinking and shifting physics is one way of exploring these mysteries, of feeling our way into the unknown through imagination and wonder. Even if the specific idea proves incorrect, the act of considering it might lead us toward deeper truths. Perhaps consciousness and physical laws are more intimately connected than we realize. Perhaps the universe is more participatory than we imagine. Perhaps we're not just observers but co-creators, not just products of cosmic evolution, but participants in its ongoing development. As this documentary draws toward its close, though never really ending, for how can wonder truly end? I want to leave you with a sense of peace about these vast mysteries. We don't need to solve them tonight. We don't need to decide whether physics really changes with our blinks, or whether consciousness truly influences reality. It's enough to wonder, to remain open to possibility, to carry with us a sense of the universe's vast mystery and our own mysterious place within it. The still point between blinks is always available to you. In any moment, You can pause and touch that place where all possibilities exist, where the universe is both perfectly stable and infinitely creative, where you're both a tiny, temporary pattern and an essential, eternal participant in existence. This still point is not separate from your ordinary life but hidden within it, present in every breath, every heartbeat, every blink. It's the silence that makes music possible, the emptiness that allows fullness, the darkness that gives meaning to light. You're approaching sleep now, or perhaps you've been drifting toward it throughout our journey. Sleep itself is like an extended blink, a longer withdrawal from visual observation, a deeper entry into the space of possibility. In sleep, your consciousness loosens its grip on consensus reality and explores other configurations, other ways of being. Dreams show us that consciousness can navigate realities with different rules, maintaining identity and continuity even when the laws of physics seem suspended or transformed. Every night you practice existing in alternative realities, preparing perhaps for some future state where consciousness is less bound by particular physical laws. But even in the deepest sleep, some part of you remains aware, monitoring the environment, ready to wake if needed. This vigilant awareness might be participating in reality's maintenance even while the conscious mind rests. Your sleeping brain, with its slow waves and sleep spindles, might be voting for stability, for continuity, for the world to remain recognizable when you wake. Along with all the other sleeping beings, you might be providing a kind of background hum of observation that keeps reality from drifting too far from its familiar configuration. Tomorrow, when you wake, the world will seem unchanged. The sun will rise as expected, gravity will work as it always has, the laws of physics will appear as constant as ever. But perhaps you'll carry with you a subtle awareness of the possibility we've explored tonight. Perhaps you'll notice your blinks more often, experiencing them not as interruptions but as participations. Perhaps you'll feel a deeper connection to the cosmos, knowing yourself as not separate from it, but an expression of it, a place where the universe becomes conscious of itself. The question we've explored, what if physics laws changed every time you blinked, may never have a definitive answer. But that's not a failure, it's an invitation to continued wonder. The universe guards its mysteries carefully, revealing them slowly, partially, always keeping something in reserve to surprise and delight us. We are like children exploring an infinite playground, always discovering new games, new possibilities, new ways of seeing and being. The joy is not in completing the exploration, but in the exploring itself. As you drift now towards sleep, or simply toward a deeper peace, remember that you are part of something magnificent. Every atom in your body was forged in the heart of a star. Every thought you think is the universe thinking about itself. Every blink of your eyes might be a moment of cosmic creativity, a gentle adjustment in the vast machinery of existence. You're not small or insignificant but essential, not separate but integrated, not temporary but eternal, in the sense that you are a necessary part of the universe's complete story. The still point between blinks is where all stories meet, the scientific and the poetic, the rational and the mystical, the known and the unknown. It's where questions and answers dance together, where impossibility and certainty embrace, where you and the universe recognize each other as old friends who have been playing this game of existence since time began. In this still point, there is no anxiety about whether our speculation is correct, no urgency to prove or disprove, only a gentle curiosity and a peaceful acceptance of mystery. What if physics laws changed every time you blinked? We may never know for certain, but in wondering, we've discovered something perhaps more valuable. The capacity of consciousness to imagine beyond the apparent, to question the given, to participate creatively in the ongoing conversation between mind and cosmos. We've remembered that we are not just in the universe but of it, not just observers but participants, not just products of physical laws but perhaps in some mysterious way, they're co-authors. And so we return to where we began, but with deeper understanding. The question remains open, the mystery unsolved, the wonder intact. Tomorrow you will blink thousands of times, and each blink might be exactly what it seems, a simple biological function to moisten your eyes. Or each might be a moment of cosmic participation, a vote in the democracy of reality, a gentle influence on the laws that govern existence. The beauty is that both possibilities can coexist in the still point between certainties, in the quantum superposition of maybe. Thank you for joining me on this journey through impossible possibilities and possible impossibilities. Thank you for lending your consciousness to this exploration, for adding your wonder to the collective wonder that keeps the universe interesting. As you close your eyes tonight, not just blinking but entering the longer darkness of sleep, remember that you are part of the cosmos dreaming itself into existence. Your blinks, your breaths, your thoughts, your dreams all contribute to the vast, beautiful, mysterious process by which the universe continues to create itself, moment by moment, blink by blink, forever and always, world without end. Rest now in the still point between blinks, between breaths, between moments. Rest in the peace of not knowing, the joy of wondering, the beauty of being part of something infinitely larger than yourself, yet intimately connected to your smallest gesture. The universe blinks with you, breathes with you, dreams with you. You're never alone in your wondering, never separate from the mystery you contemplate. You're the universe wondering about itself, and that wondering might be the most important thing of all. In the end, which is also always a beginning, the question is not whether physics laws change when you blink. The question is, what does it mean that we can ask such questions? What does it mean that consciousness has evolved to the point where it can contemplate its own relationship to physical reality? What does it mean that the universe has produced beings capable of wondering whether they participate in its fundamental operations? These are the deeper mysteries our journey has revealed, mysteries that will remain long after tonight's speculation has faded into memory. Sleep approaches now, that daily journey into the unknown, that regular reminder that consciousness is stranger than we usually acknowledge. In sleep, you'll explore realities unconstrained by waking physics, navigate dimensions of experience that have no names, be both yourself and not yourself in ways that would seem impossible if you hadn't experienced them every night of your life. And tomorrow, when you wake and blink your eyes open to a new day, you'll rejoin the great collaboration of consciousness that maintains and perhaps creates the reality we share. The still point between blinks is always with you, always available, always offering its gift of perspective and peace. It's the place where all possibilities meet but none overwhelm, where all questions resonate but none demand immediate answers, where you can rest in the simple wonder of being conscious in a universe that somehow permits and perhaps requires consciousness. This is the gift of our speculation tonight. Not answers but deeper questions, not certainty but richer uncertainty, not conclusion but continuation. And so, as our time together draws to its gentle close, I leave you with this thought. Every blink of your eyes might be a small miracle, a tiny participation in the vast miracle of existence. Whether or not physics changes, whether or not consciousness influences reality, whether or not our speculation touches truth, the fact that we can wonder about these things is itself the deepest mystery and the greatest wonder. You are that wonder, embodied and aware, blinking your way through a cosmos that might be blinking back, dreaming a universe that might be dreaming you. Good night, gentle explorer. May your dreams be filled with impossible physics and beautiful mysteries. May your sleep be deep and restoration complete, and may you wake tomorrow with eyes that see the world fresh, as if for the first time, knowing that in a sense it might be a world subtly renewed by the night's journey through alternative realities, a world kept stable by the collective dreams of billions, a world that exists in the still point between what is and what might be, forever poised in the eternal moment between one blink and the next. The universe continues its dance, with or without our understanding, but never without our participation. Every blink is a beat in the cosmic rhythm, every breath a note in the universal song, every moment of consciousness a verse in the infinite poem of existence. You are part of this, always have been, always will be, even when you're not aware of it, especially when you're not aware of it. The still point between blinks is not a destination but a recognition that you are already there, already home, already part of the mystery you seek to understand. And with that recognition, our journey together comes to rest, not in conclusion but in continuation, not in ending but in transformation into whatever comes next. The question remains open, the wonder remains alive, the mystery remains beautiful, What if physics laws changed every time you blinked? We still don't know. But in not knowing, we've discovered something perhaps more precious. The joy of wondering, the peace of mystery, the beauty of being conscious in a universe that never stops surprising us. Sweet dreams, fellow traveller in the cosmic mystery. Until we meet again in the still point between blinks, in the place where all questions dance and all possibilities sing, in the eternal now that exists between one moment and the next, between sleeping and waking, between knowing and wondering, between the universe and you. Though perhaps in the end there is no between at all.